has the run as administrator for the factory IO so that he can.
Oh, you just can double click and
Yeah. But I don't know how to make the thing work.
Okay.
Yeah, for this also is.
Hmm.
It doesn't matter what I put. This one I should change to start.
No, the PLC will be in stop mode.
So it's it doesn't matter if it is broken, right?
No problem. Slowly learn lah how to adjust. Add on outputs.
Oh, it looks really. Oh, because I forgot to put the output, right?
Yeah.
Yes, this is how
Okay.
I forget.
Go ahead and put the output. That's the I/O lah.
Where we stop? What is it?
Analog.
Huh?
Analog operator.
Oh, I don't know.
Create a new project, then open up my slide. Edit, yeah. Page edit. Yeah. So far we learn digital, right? Digital very simple lah, just on off signal. Okay. Analog means you will have a range. Okay. So like example, like this pressure transmitter, right? You make it bigger. Okay. You can see like the pressure transmitter. It can measure 0 to 250 millibar, and the analog range is 4 to 20 milliamp. Okay. The down there DC 10 to 30 is to power up the module. It's a DC lah. So normally DC 24, most of the module can power on 15 to 30.
Maybe.
I mean the range lah. So let's say this PLC, if you want to power on the PLC, it's a 24 volt, right? It still can power on if it's reach 50.
Oh.
50 to 30 normally lah. Okay, or sometimes it's like the lowest is 20 volts. The highest maximum is 30 volt. More than that, of course, like you burn or something like that. Okay, so that's what they mentioned here. Okay, so this is not the range. The range is 4 to 20 milliamp. Okay, so what happens is you can measure the millibar 0 to 250 millibar and give the PLC 4 to 20 milliamp. Okay, the same goes for this temperature transmitter. This one you can measure negative 50 to 150 degrees Celsius. Okay, and the out, you see the out is 4 to 20 milliamp. Okay, so this is the range, analog range. So analog in industry, in PLC industry, you have two types. One is voltage and one is ampere. Okay, the ampere also is in milliamps. Okay, the voltage also, the maximum range lah, negative 10 to positive 10 volt only. Okay, so some is just a positive means just 0 to 10 volt, 1 to 5 volt, 2 to 10 volt, but maximum is 10 volt, minimum is negative 10 volt. Into the PLC. Go to the analog input. Okay. Same goes for the ampere. Ampere, the lowest is 0 and the highest is 20 milliamp. Okay. So there is some module that is 0 to 20, some module 4 to 20. Okay, so common. So very common is 4 to 20 and 0 to 10. Okay, that is analog sensors. Okay.
Actually, the ampere is without the H.
Oh, okay. Next. Okay. You see how it works. Okay. So let's say we have a transmitter, flow. I mean pressure, flow, temperature level. Okay. Humidity, gas. Okay, because some of the sensors are gas sensors. Okay. Gas, humidity, then what else? Weight, all that is a value, right? Okay, so we need to have a transmitter, so it will convert those values, okay, whether it's a pressure or temperature or anything, values into voltage or milliamps. Okay, I connect that into a option board or a module. Okay, or like this PLC got built-in analog input. There's a 2 analog input right built-in. Okay, connect. In the CPU, I will get this is the range. Yeah, in integer. Okay, in integer, I will get this in integer. Okay, so whatever the model, this one is a meaning. Okay, it means okay. Because 0 to 10 also is 0 to 27648, right? 0 to 5 also 0 to 27648, right? It depends on what are the settings you do. Okay, because your built-in PLC, built-in input is a 0 to 10 volt only. We cannot see that because it's already because it's already you add a module there, so you can see here. You see here.
Actually, do we even use this one? I think we use this one.
This one.
Yeah.
See AI 2 times 10B 0 to 10 volt. You see? So you can only get set 0 to 10 volt. Like, okay? If you add an analog input module, somebody is analog output. Okay? These are the same. It's analog output, I say. Voltage also can, milliamp also can. So you can choose. Okay? In the, when we do the hardware configuration, right? Then we can do the settings, right? In the settings, you can change that. Okay? Right. So from where I get this number is from the manual. Manual. Okay. So different PLC, different value. Okay. But what is the good thing is Siemens all the 300, 400, ET200, S7-1200 and 1005. This is the range. Okay. That is the maximum range. Okay. S7-200 is different. For S7-200 is 0 to near to 32,000. Okay. Then different PLC different like Mitsubishi is different. You see like this, right? You have a built-in input, then you can add modules, right? Okay, all same only. Okay. Like Omron, Mitsubishi, built-in is very small number, like 0 to 4,000 only, the range. If you add a module, some module is 0 to 12,000, some module is 0 to 16,000.
You mean
The range, yeah, the value. This is called digital value. This is analog value, this is digital value. Okay, so Japanese PLC, the name they put AD converter, analog to digital. Okay, so how it works very simple. So this is the CPU. I have an analog input card. I have a transmitter. Let's say this one is connected to a temperature lamp, for example. Let's say 0 to 150 degree. Okay. So of course I can connect this to here, right? So I need a transmitter. Only for temperature sensor, they have a transmitter. Okay, separate. Okay, like this. This is a temperature. This is thermocouple. Okay, a temperature sensor. Then this is a. It's not a transmitter. This is a temperature controller. Later we can connect this one. At the same time, it can give 4 to 20 milliamp. But your PLC is voltage. So you can use a resistor to convert the voltage to milliamp. Okay, okay. So only for temperature sensor you need something like a controller or transmitter. Just now we see, right? Temperature transmitter. Okay. Other than that, like pressure, the flow, humidity, is already is a built-in transmitter. The sensor is already built-in a transmitter. Because you can separate it. Because why? Because PLC can read without the transmitter. Thermocouple direct can connect to the PLC. But you need a special module. It's a temperature card. Yes. Only for temperature they have a temperature card. But for Siemens I don't have, I have for annual issue. So this is the annual card. Okay. So this is a normal analog input lah. Okay. So this one you want to connect. Okay, let's say for example you want to connect this one, the temperature sensor, right? Okay. So I need to connect to the controller. Then the controller will give me a 4 to 20 milliamp signal. Then I take the 4 to 20 milliamp and connect it. Okay. Then only I can get the temperature. Okay. This one is a thermocouple module.
But what this one does is basically just change the amp voltage so that this one can read.
No. You see the thermocouple module on top. Yeah. It's a thermocouple module, right? Okay. So that module I can directly connect the temperature sensor. This thermocouple. I don't need the analog because analog means that is the range, voltage or milliamp. Okay, so I must use the milliamp. Okay, if I'm using this card, for example, this is a normal analog input. Okay, if I'm using this one, this card only can read milliamp or voltage. I can choose lah, no issue. Okay, milliamp or voltage. But so for that I need to take the signal from here to get the temperature. Okay. But if I'm using the thermocouple module, I just direct connect this, so I can get a temperature. Okay, I will tell you. I will write down. So, you see, if I'm using analog, like I said now, analog input, then this is a thermocouple. Because there's a two type. One is a thermocouple, one is a RTD. So two type. Okay. Only for temperature you have, okay? So you need a transmitter because I convert this into 0 to 10 volt or 4 to 20 milliamp. Okay? If I'm using a thermocouple card or is a temperature card, I can directly connect the thermocouple or RTD. Okay, then this is the CPU. Okay, whatever is the AI card, the function of the AI convert the analog into a digital, right? So it converts 0 to 27648. If a temperature card, it can straight away convert to a degree Celsius. But depend. For example, let's say the thermocouple is negative 50 to 1200. So be negative 500 to 1000. You will get this additional one, additional 10. Then later you just divide 10, you can get the temperature. Okay, but this card you need to choose because this one will have a time. For example, time J, time K. So later I can show you in the configuration. Okay, so only for temperature you have this card, the temperature module. Okay, like this. Okay, means the temperature sensor you can directly, they call temperature probe lah. Okay, temperature probe. Temperature probe directly can connect. Other than these, the pressure, flow, level, humidity is already a transmitter. Okay, already a transmitter. So that is a transmitter, it's a building. Okay, then only it can give you this range. Okay, in the program, what the programmer needs to do. Let's say I'm using this analog. Before that, in Japanese PLC, and they call this AD card because it convert analog to So the what is the programmer job is you must convert this number into this number. Okay, the calculation convert. Okay, it's also same. Just need to divide. Okay. Why this temperature probe, right? I cannot directly connect here, right? Okay, because this one can read means there's some voltage there, right? Voltage or ampere is there, right? Why? Because if you want to understand deeper, the thermocouple is in millivolt and the RTD is in ohm resistance. Okay, you can measure in ohms, and one is when you heat up, it will show the differences in the resistance. Okay, one you heat up, it will show the differences in millivolt. Okay, but my analog input card only can read these two only. Okay, my analog input only can read in voltage, can read in millivolt. So voltage and milliamp. So that is why I need a transmitter. Okay, but this temperature cut I can directly connect. Okay, any question? Not clear.
Not clear. I'll see when I do it later.
Okay, which one not clear? The convert the values is different lah. You can get what I mean is because okay. Okay, very simple. Okay. So let's say I have a temperature sensor. Okay, let's say I have a heater. Okay, I heat a box inside the box. I have a heater. I need a temperature sensor. I want to control the heater. For example, I need to know what is the temperature. Then only in the program I can decide when to on the heater, when to off the heater. Alright. Okay. So temperature is a range, right? Okay, it's a range. So of course I need to use analog. So that one you understand, right? Okay, I need to use analog. Okay. So my in PLC analog means I only can read in two range only. One is voltage, that is 0 to 10 volt. Okay, maximum is 10 volt. Okay. Then another one is in milliamps. Okay, 0 to 20 milliamps. Maximum is 20 milliamps. So what happened is I need to buy a temperature sensor, the temperature probe. Okay, the temperature probe. Okay, to measure the temperature of the box. Okay, but is it the temperature probe only enough? Not enough. Okay, because why? I am using a normal analog input card. For normal analog input card, I need a transmitter. Because if the temperature probe only this temperature probe, this is called thermocouple. Okay, if 2 wire is thermocouple, if 3 wire they call is RTD. Okay, they call PT . Okay. So if this one only, if I direct connect to the PLC, I cannot get the value because this is a thermocouple. Okay, thermocouple, the range is in millivolt. Okay, so that's why I need a controller, that is a temperature controller, a transmitter. Transmitter, we go back. We look at this. Look at this. Okay, but they say, can you see? They say the signal is pretty under, right? This one means this one is for the RTD module. RTD they call PT PT100. Okay, PT100 is very simple. PT100 means, you know what? PT100 means, because like I said, it's a ohm, right? Okay, you have a 3 cable. Okay, if you measure 2 point, if the temperature is 0, you will get 100 volt. If the temperature is 30 degree, you will get 130 volts. That is called the PT . So they have a PT100, PT500, PT1000. Okay, it depends on how big you can can detect the numbers lah. Okay, the higher the temperature value, you must use the PT1000 bigger numbers. Okay, the resistance. Okay, so I cannot directly connect, right? So I need a transmitter like this, or a controller like that, a temperature controller. Because temperature controller, you can see, you take, you see, number 15 and 16. 15 and 16 is a 420 milliamp. Okay, can? Okay. So until here lah, this one okay, this one I wish you understand lah, right? Okay, because it's just a converter. That's how it goes lah. Okay. Why I give you this example? Because if you are using a temperature sensor, you can have optional temperature card. If you are using a temperature card, the temperature probe, right, the thermocouple, I can direct connect it. So in the PLC, I can directly get the temperature value. Okay, good. Okay. So why I need to do this? Okay, when I get the temperature in the PLC, then I can do some comparison. I put a set point, right? Set point, then I can compare them and I can control the heater. Okay, so that is function of the analogs. Very simple. Okay, like I said, like this, like I said, the temperature probe, right, you need to connect here. Okay, then only you can get the in the milliamps. Okay, but if you see the pressure transmitter, it's already a transmitter. There's no like an external like this one is a temperature probe, right? You have external, that one it's already building. That's what I just want to give an example lah. Okay, the flow meter, temperature level, all that is already together with the transmitter. So that's why, other than temperature, you don't have a special module. Like for pressure card, you don't have a special module. For flow meter, you don't have a special module. Only for temperature, because it's two separate things. One is a temperature probe, one is a transmitter. Okay. Okay. Next. Okay, go to next. That is for output lah, output later. So what we need to do is, we need to convert the digital value, the value I get, right, into the, depend on what are the sensor we use. Okay, let's say it's a pressure, how much? Okay, you can use the formula y equal to mx plus. Okay, the linear equation. Okay, you do the calculation, right? But Siemens already give you the block to do the conversion. That block called norm x scale x. Okay, so you can use that block. You can key in the minimum value, maximum value, minimum value, maximum value, and your analog input. You can calculate and you can convert the value. Okay, so that's what you are doing. Okay, minimize this. Okay, no. Before that, go to this full menu. The second one, S7-1200 full menu. Okay. Position full menu. You click the technical specification. Go down. Okay. You are using 1212C, right? Okay, click go down. Analog input. Okay, click. Right. See, this one is the analog input. That is connected to your PLC, right? I mean the built-in MI. So number of input is 2, voltage, the range is 0 to 10 volt, invert is 0 to 27.6 volt. Overshoot, I can still overshoot to this value, okay, but it's like overshoot, overflow the number, okay. The resolution is 10 bit. 10 bit means because sometimes you buy there's a 10 bit, 12 bit, 13 bit, 14 bit, 16 bit, okay. Means the resolution means how fine the value. Okay, how accurate you can get the value. Okay, go down. Okay, this one is what we call the sampling time. Okay, so you can choose 60 hertz, 50, 100 hertz. Okay, sampling 10 hertz. It means how frequent the PLC will read the data. Okay, if let's say that if the time is very small, like this, right? Okay. For example, 4.172 seconds, okay. Very fast, like scan every time, every 4 seconds is scan. So if a small changes also it will update. If I choose 25 milliseconds, it means every 25 milliseconds only it will take the data. Okay. Sometimes got higher also, got 100 until 50 milliseconds also. But this one is a built-in, it's different. Okay, go down. Okay, this one is the built-in. Okay, go down. Okay, other one built-in. Okay, go again here. Okay.
Oh.
Go again down. Okay. Okay, digital. Okay, analog modules open. Okay, analog. Okay, this one is the modules like they have connected, like additional module.
Down.
Yes. Okay, not down here. The additional modules. Your PLC.
No, this one.
Yes. Okay. Go down. They call assembler signal modules. Okay. So they have. You see, one is AI4 13 bit, AI8 13 bit, AI4 16 bit. Okay. Go down. Okay. So you see the AI4 and AI8 it can measure negative, positive 10 volt, negative, positive 5 volt, negative, positive 2.5 volt. The range okay. Then 0 to 20 milliamp or 4 to 20 milliamp. This was the same okay, the same thing. Okay, 1.25 also. Very small also. Okay. Okay, go down. Okay, go down. Go down. Then they show you how to connect. Okay. 2 wire, 4 wire, go down. There will be a table. Go down. Go down. Go until you see a table. Okay, go down. This is for the analog output card. Okay, go down. Okay, check. Okay, you see where's 27? Okay, you see 10 volt also it shows 227,648, right? 5 volt also 27,648. 2.5 also 27,648. 1.25 also 27,648. Okay. What this means? This one means it depends on the settings I do. Okay? Like this. Let's say this is the AI card. Positive lah. One. Let's say I choose 0 to 10 volt. Okay? Setting 0 to 10 volt. Okay? Then if I connect 0 to 10 volt module, So the range in the PLC will be 0 to 27648. Same lah. Same if I choose 0 to 5, because they put negative 5 to 10, means negative 5 to positive means you will get negative 27,000. Okay, procedure. Negative 10 is 27,648 and positive 27,648. Okay, but you don't see the negative lah. Let's say, so this one 5 means the same number. Let's say this one is only is 10 volt. I choose only 10 volt. But my device is 0 to 5. Right? So in the PLC, I have half of it. Yes. You got it? But sometimes some people will confuse. They confuse. Okay. They will ask me, okay, you said 0 to 10 means is 27648. So it means if 0 to 5 also must be different, right? But what they said is 27648 because based on what I select here. So means whenever I do, Siemens or some other also can choose. Make sure the setting in your PLC, the hardware and your device also is the same thing. Then you can use this number. But let's say that for now, my built-in is a 0 to 10 volt. Let's say I only buy a sensor that can give 0 to 5 volt sensor. Okay, so when I connect, I must program, I must calculate. I can use this number. I must use the half of this number. Okay, so that's how it works when you do the calculation. Okay, when you want to convert values lah. Okay, alright. Okay, let's minimize this. Go to their portal. You can new project or you want to open up a new project. So just add the two modules. go to the configuration. Okay. You bring it up this one. No, this one this window. Bring it up. Okay. See the property. So this is your property of your CPU. Okay, go up. Slowly go up. Okay. AI 2, right? Analog input, right? What? Channel 0. Okay. You see the address is IW64. Okay. Why? Because you can see I start with 64. Okay. And the measurement is the voltage. The voltage range is 0 to 10. The smoothing just now we see, right? The scanning. How fast the sample time? That is called the weak slug. Okay, 32 cycle. That is a very slow reading. Okay. So this is the range. I cannot change. Okay. The AQ1 signal board. Okay. Go to analog power. Okay, channel 0. You see the signal board I connected is a QW80 because it's an 80 here, right? Okay. And can you see I can change the range, voltage or current. Okay, because it's a special module. So you see on the module, the small board, the signal board, they put it there. Voltage or milliamps, okay? No, right? Okay. So we leave voltage lah, then only easy to read. Okay. And now, we add one AI card and the side here, just to see only.
Where?
Here. Okay. You see, this AI, you have AI4, AI4, AI8, and you have a RTD and thermocouple module. This one, right? This one is like this one. So there's a 2 for RTD. RTD means I need to connect the PT100, PT500, the one with the 3 wire. Okay. If a TC means I can connect this one. Just thermocouple. I can direct connect. Okay. So first you choose the AI4. I show you.
Basically, this one is a special card.
Special card for temperature, temperature card. Very easy lah. Easy to understand. Okay. Just add one. I want to show the setting.
This one.
Yeah. Later we can edit. See, this is the AI for the properties, right? Okay, click here. Channel 0. You see, the address is okay, whatever you setting lah. You see voltage, right? I can choose between these voltages. If I choose milliamp, so I can choose this. Okay. Okay. So you delete this. You add a thermocouple card. Yes. You add a DC card. Go to DC. Okay. You see, it's thermocouple lah. You see what? You click the thermocouple. So you're using a thermocouple or voltage. Okay, voltage means it means still a millivolt lah. Okay, it's millivolt. Okay, or thermocouple. Okay, why they say got there is an option for deactivated also. Right. Okay. If let's say you add this module, then you can connect 4 thermocouple. Okay. Let's say your system got 2 only. The other 2 you must deactivate. If no, it will show like open circuit. Then it will show error. Okay. Thermocouple. Then like I said, the type, right? type J, type K, type B. So you need to refer to the manual. In the manual also got the stuff. Okay. So they have different ranges. Okay. You go to the menu. It's got the menu. Okay. You click here again. Go down. Okay, under 1, 2, okay. No, not this one. Go down. Okay, analog signals. Okay. Go down. Okay, it's the thermocouple and RT. Okay, thermocouple. Okay, just click the thermocouple. Yes. So they tell us what to do. Okay. Okay. You see, type J means nominal low limit, negative 150 to 1200. That's the range. Okay. So why they give you this one? Because you need to know what temperature module you connect. So then only the value you will get here. Then only you can do some calculation or something. Okay. So this is the range. So you straight away will get this number. Is what they show. 150 to $1,000, right? But 150.0, correct? But my temperature input is IW, correct? It's IW input word. The word cannot keep decimal point number, right? So that's why in PLC I will get 1,200 to 5,000. The range inside the PLC. Okay, okay. Go down. I think it will show here. Go down. Wait. Value the under range. Okay. Okay, go down. Okay, for example, representation negative 150 means it will show 150 in the decimal number. Okay, in your PLC, right? Okay. If 1,200, it will show 12,000. Okay. Alright. So
why do they have to use integer and not just times time? Why not just use double int? Why not just use double int?
Double integer.
Yeah.
No, cannot, because analog is always integer, 16-bit data. Okay, that's number one. Okay. But like this, if let's say I want to get exactly this number is in real floating number. But my analog is a word. Right, it's an integer. IW. So I cannot accept. So that's why in the PLC they add another 0. So that you can divide to 10, so it will make it exact range. Okay, go down. This one for RTB. Okay, RTB. Okay, page 12060. Go down. Show you that. Go down. RTD also they have their equal. What is this? Selection. Okay, like I said, the RTD type. PT 10, PT 50, 100, 200, 500, 1000. So this is the range, minimum and maximum range. Normal, nominal range, low and high. So negative 200 to 850 for the PT 10. Okay, go down. So you must choose the correct. When you buy, you know what is the what, because some is nickel, some is the copper. Okay. So very simple. That is, anything you want to do, you can refer to the manual. So in the manual, they show what is the value. So in that, you know how to do calculation. Okay. So now go back to the CAD model. Okay, so this one can remove lah. Yes. Okay, so what I want to do now is, okay, for now, we just want to use this. This is a signal injector. This one can inject 0 to 10 volt, 4 to 20 milliamp. Okay, it's a for training purpose lah. You can use. Because this one is a voltage generator, potential meter. So you can generate voltage or current. So that's this voltage, right? So I can use this. Okay. The temperature sensor later. So what you do? You power off this. If I connect the 24 and ground is zero. 24 and ground 0 lah. Okay. Then ground AVO voltage lah, right? Let me see. The ground is 2 amp. Not into, right? So the AVO and the ground. So the ground is 2 amp. The first zero, the first input is the differential voltage. Yes. The power of first. First, what we want to do is, okay, so you connected to the first input, right? So what is the address?
Zero.
No. Your analog.
So it's AE.
AI. You connect to the AI, right?
Or input.
So IW64. Okay. What we do, you go to the watch table, you check first, add new watch table. Then you click monitor. Click monitor.
Okay.
be fluctuate a bit. Because you know what, will always connect, disconnect, right? Training lah. Okay, yeah. Okay, so that is just a signal generator lah. Okay, it's not a transmitter lah. It's like it's like I just give a 0 to 10 volt to check whether it's good. So that one I can assume anything. It can be a pressure, it can be a temperature, right? So let's say that I want to do this one. Let's say the one you connected is a temperature sensor 0 to 150 degree. Okay? So if you put 10 volt, then in the PLC I need to get 150 degree. Okay? So we see how to do the program. Okay, you add a FC lah. We do in the FC. FC, okay, you put name analog scale. Okay. Then you go to the main, you add you call the block FC. Okay. Then you go back to the FC. Go to conversion operation. Can you see norm X, scale X? So you add the norm X first. Okay. Scale X. So, whenever you want to do, the best way is do a graph. Okay, so this is my AI value, right? That is 0 to 27648. I want to convert to temperature. So always your x-axis is the norm x, okay, and your y-axis is the scale x. Okay, very simple lah. They normalize this value and they multiply with this range, you will get temperature. Okay, so the norm x minimum is what? 0. Put 0. Enter. Okay. Because you didn't choose the data type, okay, choose the data type. Okay. Okay. You see, where norm x is your AI. Your AI is what? Data type. It's an integer. Okay, choose integer. Yes. Then this one must be a real. Then this one must be a real. Same like this one. Because this one, wait. Because this one, because whatever the result, I will put it here. Okay, so means it will do some calculation, put the result here. Then I take the result, I just do calculation with the minimum maximum, I will get out. So this output is depend on you. Whether you want in decimal point, you choose real. If you just want a normal number, choose integer. Okay, okay. Now. Okay, you put all the minimum x.
This one also 0.
Yes, minimum 0.
0 to 150.
Yes, correct.
Wow.
Okay, now. So this is my the 0 to 27648 from where I get my analog input, right? What is my analog input address? IW64. Correct. IW64. You rename, you put AI1. Then this is the result lah. I can use memory lah, or I mean FC, right? Then I want to take this number to just just want to transfer here only. Right. So I can use the temporary.
Just put
Temporary, yes. So what is the name you want? Now you can just put the norm X out. Norm X out. Any name you can put, but I prefer that norm X. It's okay. Yeah. Okay. But what is the data type? No.
real.
Yes. What is this data type? Real. Okay. Yes. Then actually you can drag. You can drag and put it. Same thing. Okay. Then this one bring it up. First one. And this one, then I put memorial. Because later this is the one I want to show in my HMI. I want to use for my compare, all that. Because that is the temperature value. So put MD. Because the real MD is here. And then you rename temperature. Put temperature 1 now. Okay. Alright. That's all. Okay? If I don't have this one, I have to do my own calculation now. For many way to do calculation, okay, but the normal one, the one we study always, 1 equal to mx plus c. Okay, so y is the temperature, m you need to find out. Okay, m is delta y over delta x. So if you want to delta y is y max minus minimum, delta x is x max minus x minimum. Then your x is your AR. C for this don't have
0.
0 lah. But in case in the future you have C is equal to y minimum minus m x minimum. So you see how many calculations you do. Okay, do this one, do this one, do this one first, then only can do this one. Okay. Or unless, because this one got calculate. Calculate means you can under max, go to max. Can you see the first one? Calculate. You can put formula. So you can directly put m is equal to y max minus y minimum divide this. Then c is equal to this. Then finally this one. So means you need to do calculations. Or you can do this calculation in the structure text. Also can be later do. Okay. You deal this one. And if you don't have that, you can use this norm X relax. Okay. It's save, download, and test.
Where do I output the value?
Which output value?
How do I see temperature?
In the MD0.
I just use the watch table.
No, you can see here also.
Oh, okay.
Because when you monitor, you can see the number here.
Alright. 5 volt, it will be so stable. Like for some reason. 6 volt.
What also will be stable?
No, if you see, if I put in like 6.3 now, you see the thing is keep jumping, the temperature keeps jumping, and then if I put like the whole number,
Yeah, because that one is because of that lah. Because you give exactly 6 volt, right? So means you get exactly 6 volt. Like if you put 5.9, there it will show 5.9. But if you measure, it's like 5.999 something.
wait, it's also stable.
So sometimes it's stable. Normally when you go to maximum value, or sometimes it won't be stable.
Oh no, because I touched the
mid potential, which is it.
yeah, I touched the thing. You keep jumping. Okay, I think it's the. Actually, this non-X out is just a percentage, right?
This is 0 to 100%.
Huh?
It's just like 0 to 100%.
Yeah.
Convert the value. Then, like this one now is a 50%. 50% multiply under 50, you will get 75. That's all. But there is inside the calculation also, because you know why? Because later you have a minimum, maximum is different in the calculation. Okay. So what we do with this one? After we do the scaling, right? Then we can show this in your HMI. We can use for comparison. Compare all that. Okay. Now, let's say I want to connect that temperature sensor. But that one is a milliamp, Okay. So what I do is milliamp means I cannot connect. So I need to convert to voltage. So if you, because there's a 420, there's a two cable, right? Positive, negative, right? If you cross a 500 ohm resistor, you can convert to voltage. Okay, wait a minute, see what happens. This is your AI 0 to 10 volt. But your transmitter is 4 to 20, right? So when you connect, of course you can get. So what I need to do, I need to connect a resistor. So if I want to find what is the resistor, V equal to IR, right? So means R is equal to V over I. So R is equal to voltage is 10 volt, maximum, right? Then the current is 0.02 amps, so you will get resistor 500 ohm. But if a opposite means that, let's say this is the milliamp and this is the voltage, right? The resistor you need to use in the positive side, not across. Okay? But let me measure this one. Is how many. What's your 2, right?
Wait.
This one is 500 ohm. go to the number 1 lah. Okay. Then 16 is 0, right? It must loop with the 2M. Then this one you connect like this.
Wait, huh?
You can connect here also, can connect here also.
Oh,
Just need to cross up between the positive and negative. You can connect here also. Okay. That one no. Here means the 2M and
1.
1. Okay. This one is only the table of this table. Okay, don't just stop. Because I want long here. This one positive. One for the
Then I have to power this on.
yes, need to power on.
It's on the
Yep.
release cache.
Now the temperature is 28. Okay, go up. So setting the range here, the setting is 0 to 100. Okay, but this is a 420. But now I convert to 0 to 10 volt, right? So it won't convert to 0 to 10 now. Okay. So when I do this one, so it will convert to, because it's not a 0 to 20 one. So when I get now is the 420 will convert to 2 to 10 volt now. Okay. So 2 means it's not 0, right? Okay. So how much?
But I don't really understand why is it 2 to 0? 2.
Yes, because according to the calculation, right? 500 ohm, okay. If 20, I want to calculate voltage, right? Okay. So I is 0.02 multiply 500 ohm, I will get 10 volt. So for this line, if so it's a 2 volt. So 2 volt means because
2
my what's it?
Yeah.
Correct.
Yeah.
So if my PLC is 0 to 10, right? It's not a 2 to 10. 0 to 10 means I start from here. Right? Okay. So what is the range? So 27648 is 10 volt means 1 volt is 2764. Divide 10 lah. If 2 volt means you plus this one, you will get what do you get?
Plus this one.
I mean times 2 lah, right? Two 764.8 times 2.
Times
2 volt. 1 volt is 2. 1 volt means so 2 volt means 55.
2.
So I put 5530 lah. Okay. So for second one, okay, you do the same thing for second one. The normal scale X.
Under the same thing.
Yeah. Because it's another one. Integer. It's also real lah. Okay. Then what is this address? It's a second input, right? So IW.
This one is also the max, right?
Yes, max is correct because 10 volt, right? Is a 100 lah. Okay. So this one is a new one.
But actually, why? Okay, this value is shown here only because I connected it, or what?
No. It won't connect also. I can show you.
You can show this value also.
Yes. Because the function of the temperature controller is I connect the temperature sensor, then I can do some set points there to get the output. Because if you see the diagram there, you have output. This diagram. Here you can see got out 1, out 2. Okay, then got alarm also. So let's say I can put it. Okay, now 30 above, right? I put a set value 30. 30 above, out 1 is on. Below 30 is nothing. Then maybe I need to put some other settings. Maybe if more than 60, out 2 is on. So I can use that. No need to connect to the PLC.
Connect to the PLC is just to
Just
control
to
the other
show,
machines.
Show, and I can control so many outputs. This one only can control 2. Can get only 2 comparisons. Means here I can do only 2 comparisons. But this value I can do any comparison. I can show in the HMI on it. But normally, why they add this one? Because sometimes they don't want to buy an analog card only for maybe 1 or 2 temperature. Because what I want to do, I want to go take the temperature and I want to control one motor, for example. If the temperature is higher than 50, I want to control, right? So for what I want to buy one, I can use this one. I set here, then I just no need to connect one temperature here. Just use the output directly connect the motor. Or this output I can connect to my input, right? Then I can control my motor. Also can. Okay, but I add this one, so I just use for training lah. Okay, but sometimes I just also they use. You put it here. Maybe this one directly control some device. At the same time, I want to show the HMI in my. I want to show the temperature in my HMI also.
Okay, now it's lower than 30, but it still shows up.
I'm not sure why this one is. Please number. Out one is for what? Maybe lower than that or what? Just because I don't have a normal transmitter at the round one. So if you put 0 here, right, then you won't get a proper value, right?
This thing is only giving out 4 to 20 milliamp. So it will convert, and also
I need to use a resistor to convert, and also I need to do unless let's say I use an analog card and I choose 4 to 20 milliamp, then I can directly connect, no need resistor. Then here also I just use 0 to 27,000. Because why? My AI also 4 to 20 milliamp, my device also 4 to 20 milliamp. So I don't need to do this calculation, all that. Just directly can use 0 to 27,000. Okay, can you see? Okay, we take a break. And after the break, we see how to do for analog output. Do scaling for analog output. Same thing, only the out will be output will be at the output side. now we are doing is a scaling for analog input. Means I get the value, I convert into the unit. Analog output means I set point, I set value in what? In the unit, then I need to convert into analog value.
又不是学你那个，没有，这个是普通 potential meter 到没 control 这些。
Okay, good. Now for analog output, can I erase this?
Yeah.
For analog output, it's the same thing. from the CPU, I send this value lah, right? My analog output will convert this value into analog value. That is 0 to 10 volt or 4 to 20 milliamp. So this one in normally Japanese PLC and they call DA module, digital to analog converter. Okay. Then normally where I use, okay, normally like inverters. Inverter means like your VFD lah, your drives. Drives they need to control the speed. Okay, or sometimes they call temper. You know, if you want to increase the pressure or you want to let go the air or there's a damper. Means there's a motorized damper. Okay, or valve, because some valve is just open and close. Some valve you can open how many percent you want, 0 to 100%, right? Okay. So if you ask me, analog is to control anything that is motorized. Means anything that have a motor, you want to control the speed, or you want to control adjust the rotation. Okay. So this one, let's say go to a motor lah, 0 to 50 hertz, right? Okay. So earlier you see, analog input is I get the input, correct? I get there is a temperature, I get in milliamps or voltage in the PLC, I get some value, then I need to convert to the temperature. Now analog output means you need to give, same like your digital output, right? You need to know, you decide, right, when to on, when to off, for example. Okay, same thing. So what I need to do is same, I need to convert also, because of course lah, let's say I want to run the motor 50 hertz. So means very simple lah. So your analog output is a QW80, right? Your analog output, the address QW80, right? Okay. So if at QW80 you give this number, it will convert to a voltage of milliamp, go to your inverter, then the motor can run 50 hertz. But let's say I want to key in the HMI, I cannot key in this number, right? I must key in this number in the unit, so I must key in. So I must set in 0 to 50 and I convert to 0 to 27648. Okay, so you need to key in and convert. So same thing, I can use the norm X X. Okay, so let's say you want to key it, then we can measure that. Okay. Okay, you add norm X X. Okay. Real, okay. Some real. Now this one is a integer, because like I said, this is your norm X, this is your scale X. So your norm X is your set point, correct? So here will be your set point, here will be your analog. So this one now, in this case, this one you want to use integer or real is up to you. Because like this, the value is IW64, so I'm at 66. I must use integer. This one is depend on you, right? Because this is the input. For output always must be at the output, right? So this integer is a fixed, because according to my output.
The 3 is a flip lah.
Yes. Because this one very, the participant very hard to understand. Okay, because they stick with the name analog. Analog, yes, correct, but there is an input output, correct? Okay. So here you put the QW80. Okay, you AQ1. Okay. So what is the range? For the AQ1, what is the range?
0 to 7.
Yes. Okay. Then this one is minimum. Then this one I need to create another one, right? So just drag one.
Is this the same? Can I use the same thing?
Can use the same thing.
Or
Yes.
wait. Or
Okay.
or wait.
Yeah. And this one must be a memory because I want to key in. So must be MW what?
6.
6? No.
Or 4 already used to
Yes. Yes. So you rewire.
Where is the like
The one can be so can name it speed set point, for example. Speed set point. Speed set point.
speed.
Yeah, speed.
Speed. Or speed.
Yeah.
Or we try to set the speed of
Yeah, that is speed. So when I key in like 50 hertz, then I will get a 27,000. So 27,000 equal to 10 volt. So when I connect the motor can run full speed. Okay, same. Yes. So you get 25, right? Half, right? So you measure the voltage.
at AQ.
It's a EQ.
Yeah.
Yes, it's correct.
So it's 0.
Yes, correct.
This one. Where is it?
No, 0 M and 0.
I think I flipped it. How much is it?
So this one you connect to the valve will open. Okay, good. Any question here? Okay. What I want to do, I want to do what is it? One structure text for the calculation. What's structure text?
Structure text for what?
For the calculation.
Calculation.
So this one is because they already give you the Normax KLS, right? So you do that. Let's say you want to do your own calculation, for example, you can do so. So because at the same time, it's like we learn the S structure text also lah. Okay. So it's up to you now whether you want to use FC or FB. Because what I want to do is something like, okay, I do one block, then I can use one block. You know, something like that. Okay. So want to use FB or FC? Choose FB. You put name scaling. Okay. Then the language SCL. Okay. So you go to the local type, local variables. Because I want to do the old style. Okay. That is the last this is the formula like mx plus. Okay. The first formula is m is equal to, first I did y is equal to your output. So I don't want to fix any name, temperature or pressure, because this is a standard block. I want to use many times. Okay. So that's why is the name I put at the scale value lah. Okay. Okay. Now then M is the ratio lah or rate. Okay. X is your analog input and C is the offset. Okay. Now so this is the third calculation we want to do. Okay. The first calculation is M is equal to y max minus y minimum, x max minus x minimum. Then second calculation to find the offset is y minimum minus m x minimum. Okay. Okay. You see, because let's say the y max is one. I need to do calculation. You must use real. Right? This divide lah. I must use real. Why I need to use real? Let's say in this case, means the y divide x. So when this one divide this one, I will get some point numbers. Correct? Okay. Or if let's say it's an analog input, so this is a smaller number, this is a bigger number, right? Then I will get 0.00. So all my calculation must be in real, but my analog input is in integer, right? Okay. So how to do it? Firstly, in the input, what you do? You add. Let's say this block is only fixed for AI. Okay. Put analog input. Okay, then data type is integer. Okay, then I need the scale max, the scale out, right? Okay. Normally in PLC, right, that one they call, okay, you have these two value, right? Okay. Normally this name they call engineering value. Okay. This one they call raw value. Normally. Okay, engineering value. Right? So I want to use the same name. Okay. So you put engineer ENG max and minimum. ENG minimum. So these two you put real. So for AI also I have a minimum maximum, right? But the minimum for AI minimum maximum is fixed, right? 0 to 27,000. Okay? Because we are 90 hours. Because I want to do for AI. So what I want to do is, okay, this. I want to do a function block. And this is my scaled value, right? And this is the engineering minimum. This is the engineering maximum. Because it's not fixed, because I want to use multiple. Okay. So, but this number, two number is fixed, right? Right. I can use constant. Go down. AI ni AI max. Say real. Real. Use real. Okay. Then yes, you can fix the number.
What is it?
0.0.
Oh.
Okay. Then output you put a scaled value. Scaled value. Okay. Okay, put real first.
What is scale value?
The output, the engineering value. Yeah. Okay, then I want to use then I need to add the rate and the offset. So the rate and the offset
Memory.
use manual. Use internal rights, internal right. So use temporary. So you put gradient basis. Gradient, real, gradient, offset, and yeah, can it's up to you. Okay, which one you understand? Have you done this one before? I mean, structure text, no, right? But you learn C plus.
Yeah. I think I can understand.
Yeah, similar thing. Okay. Then I want to add another one because you see, for logic, right? Your M is real, right?
M is real.
Real. Your C is real, right? Your Y is real. But your X, AI, just now we put integer, correct? Because that is integer, you cannot change, correct? So, but in calculation, I cannot use integer. Real multiply integer. So, I need to do a conversion. Remember yesterday we do conversion. So, what you do? In the temporary, you add another one, AI real. Okay, good. Okay, now you can do the program.
Wait.
Okay, then you put the slash 2 times, yeah, 2 times
What is that?
beside the shift, the right hand shift. Okay, 2 minimum pula. Okay, put convert integer to real. Okay, and then take out that. Okay, so I want to convert the integer to real. Okay, so if I want to convert integer to real, put the output first. Means that is the AI, analog input, no, analog in real, yeah. So you can choose. The column equal to put int 2 real in bracket, you put input in, the 2 dot equal the analog input. close bracket, semicolon. Okay, yeah. So means I want to convert the integer to real. So the integer is this one, the real is. So always the output at the left hand side. Okay. Okay. Next, I want to do the M. Okay. Just put like this lah. Want to put this one is a comment, right? Want to put a comment, you can put a comment lah. Calculate gradient or something.
Okay.
Calculate gradient.
Oh.
Because later when you refer time, so you can understand. Okay, then you know. So always the output is the left hand side. So gradient is equal to equal open bracket y max is what? Engineering max minus engineering minimum. Close bracket divide the AI max minus AI minimum.
Wait. What is the average value? Oh, basically it's the fixed value.
Yeah, it's a fixed value. So you don't need to key in later. Semicolon.
Oh.
Okay. Then another calculation is the offset. Offset is equal to y minimum minus the gradient multiply then last one is the y. Try and see. integrated FB, right? So where to use? Just use in no, in the scaling, same scaling block. Okay, just add the FB here. Okay, just put scaling DB1. Okay, so it's like this. So means whatever is same thing. Right? But I'm using a structure text lah, okay? Or even in the I was doing one project now. I'm doing one project for UTM. They have around 9 analog scale. You know what I mean? I do like this. Actually, I can do like this. Correct or not?
9 analog scale.
9 analog input.
Oh, okay.
They have 9 inputs to do conversion. Okay. I can do like this, correct?
Oh, you don't have to copy and paste.
I do like this. But inside there, actually inside FB, I can use this one also, can also, correct? Let's say the FB, I choose a ladder. Then in the ladder, I can use this, correct? But why I do like this? To make sure that other people don't know. If they come and suddenly see structure test, right, they will say, oh, very, very difficult. They don't understand. Because when you make it easier, they can simply go and change something. So sometimes that is what they will play.
Oh. Can I just convert it to another language?
Yeah.
Oh.
Can change. Only STL can change to ladder, STL can change to FBD, and FBD to ladder all that can do. But the 1002 don't have STL, so must use 1500. STL cannot change to ladder. Very difficult. Okay. So go to the scaling block. Scaling, yeah. Okay. Now you just use back the same IW64 lah. Yeah. Okay. Then what's the engineering max, engineering minimum? Let's say it's 0 to max. Okay, let's say it's a pressure 250 millibar. Minimum is 0. Okay, that one you put the pressure. It's a new tech. MD, what number I can use? No.
D4 or MD8
Already used.
state reduced, so MD10.
Yes. Okay, so actually in the programming, right, this is important.
What is
The
that?
addressing, you know how, now you know already how to play with addressing, and the data type. Real, that is important, you know, because all these, like whatever I done here is a, what I call is a logic.
Yeah, it's
Logic you need to play around, can improve. But most important, any PLC you take, most important is the addressing and the data type. So addressing means not only the memory, so when to use I0.0. So I0.0 it means it's a boolean. IW means it's an integer. Okay, and the MD means it can be a double integer, can be a real, can be a double word, can be a unsigned double integer. Because MD have got 4 types, right? So you need to know when. That is most important. The rest you can just play, and because for so many instructions, right? Then you just go to help. They will explain how the instruction works. Then you just take one, because if you want to learn any instruction, like a timer or counter or something, a simple one, for example, a timer or counter, just go to the help and see okay how it works. Okay, they describe everything. Just drag and put. So then from the description you know there is a in means input, Q means output, PT means is a timer set value, ET means the current value, right? Then you just drag and put. So you know okay, input is in the line, so you of course you know this must be a normally open or normally closed, right? And output. Then PT, ET, you don't know what to put. Bring the mouse there. It will show whether is what is the format. double integer, double word. Or you go back to the help, they will give you an example. Then you just put the timer and just play, observe what happened. When you on, okay, what happened? Okay, timer running, after 10 seconds, output on. If I off, totally everything off. Okay, then again I start running, halfway I stop, what happened? Okay, reset back. Then when you play a few times, then you understand really how that works.
Basically logic.
Yeah, basically the logic. So most important part is the addressing. So in the line, what I need to do? Okay, I know I can put down the word, but what address I want to put? Whether I want to put IW or IB or I0.0 or 1.0 like that. That's why I say normally after this 4 days to 3 days, I say the logic you can play, because logic is different mind, different type of logic. The thing that won't change is the addressing is fixed. And that is their, what they call, that's their rule. You must follow their rule. You must use Boolean means you must use like this. Double word means like this you must use. Logic is different for different. Even I can do different way also. Okay, so just put pressure. Okay, then I can do multiple things. Right. Then actually I want to add one more also. Now maybe test. Okay, actually but no need to test. But this one you see I only can use for analog input only. Alright. This calculation, because this calculation is according to analog input.
Yeah, because the input value is word
in integer, and I already fixed this one already fixed number, right? So I cannot use this for my analog output. So monitor, of course, you know I can get a value.
I guess is the measure meter, right?
Yeah. I can do many things, that's the thing on PLC. Okay, you go deeper, you explore more, then you can do anything. Okay, because sometimes let's say the pressure, right? I don't want to show in, because it's already in millibar, right? Make your pressure is already in millibar, right? So that is not like I want to show 1 to 4.9 millibar. Okay, so I want to show in the HMI normally I have 125 millibar, right? If the value in bar, maybe I can show 1.5 bar. Because bar is bigger number, millibar is very small number, right? It's already. So in that case, I don't need real, right? I can use integer.
Oh, yeah, I just convert back.
Yes. Okay. So what I do normally, if you what you do, let's say that the pressure in the HMI, I want in integer. I don't want real. What do you do?
Just add another block here.
Another block there. You can. Actually,
Inside also can.
yes, that's what I want to do. Okay. Wait, I want to show you something. That is go to instruction. Instructions. Go to here, because the convert you cannot convert from real to integer, cannot convert.
Oh.
Okay, but never mind. You can use this one, the round up. All these are integer to real to integer conversion. Okay, round means round up lah. Seal means it will give you the next higher number. Let's say your value is 12.1. It will convert to 30.
Oh.
Next higher number lah. Okay. Floor means the next lower number. So let's say yours is 12.9. It will show 12. Okay. And trunk means it will cut off. Doesn't matter it's 12.5 or 12.9, 12.1. It will show 12. Trunk it means cut off. Okay. So all these to convert real to integers. Okay. But what I do, like you said the second one, I will add inside here. Okay, you go, I show you. You add one more output. Okay, you change this output name, scale value, real. You add another one, scale value integer. Okay. Then you add one more conversion here. No, in the program.
Oh.
So this one, so that I will have two output. One is real, one is integer. Okay, convert real to integer. Okay, so you put the integer in the output side first. That is scale value integer. Yeah. Okay. Equal to. Real, wait, real 2, yeah.
Real
Step. Real 2 integers. Okay, in bracket, in equal to the scale value lah, scale value here.
Why is there an int here? Is it a
It's not an int, it's an input.
Oh, that means this one is the input?
Yes, this is what I want to convert to this, yes.
Okay.
Some PLC, is most of the PLC is same thing like this. But some PLC don't have the int. Like elementary Omron don't have this int. You need to do. Okay, then you go up. Go back to the analog scaling. You update the block.
How about that?
Right click. Update block. Yes. So now we will have two values left. One is in integer. Okay. So what you put? Okay, you put MW 40. Yes. Okay. Then you put pressure here. So I can do this. And where? And let's say actually in this case actually I don't need this one. I just need this one. So I can delete this one. I don't want. For now I can just delete that. So whatever this FP I can call multiple times. Maybe some of that is an integer, some of that is a real. So only have one value only. The other one will always empty. Correct. Okay, only you just need to put only one enough. The other one can leave it empty. Correct. Okay. So that is the function. That is the advantage of FP. If you do this in FC and you have two output like this, both also you must key. Like this, for example, you delete this one. Actually, I don't need this one. So I can just leave it.
It won't show error.
It won't show error. It still can go. So that is the advantage of FP.
But if I copy and paste this one,
Can.
and write another one here. Then the address to put in new address one will be done.
Yeah, of course, yeah. I put new address. Even I can copy paste also. You delete this one? I show you. If you want to copy paste, what you have to do? Okay, you copy paste. So just click the block only. Copy the block. Yeah. Okay. So I need to change the DB. First thing I need to change is the DB.
So
Yes. Because I can use the same DB. So just put, never mind. Just delete.
oh, it's already there, so I just write.
No. Because just now is you created, right? I said I want to put DB3. How? You delete the DB1. Just erase. Okay, put DB3. Enter. It will create a new one. Okay? Then, of course, we will add a new one, right? Let's say the one you take up. The one you take up. Of course, you will use the MW60. Okay? Then, of course, the input also will be new input. Right? Okay, put the IW66. Then the range should change.
Wait, so you taken?
Yeah. No. We already used the up one. Never mind, just use that.
Oh.
No issue. So the change the what? Yeah, mix manual because IW66 is your temperature, right? Sensor. So put to 100. Then this one is your input. No need. Want to put MW example. Then want to use the integer. We put the temperature. Temperature 3, right? Because they already on top already use 1, 2. So that's how you see. If you copy the main thing is you need to change the DB and all the icons, which one you want to change. The best thing is drag and delete it. So you don't do mistakes. You know, sometimes you copy paste, but you straight away focus on these. Let's say so many, right? You straight away focus on this. You just change all this and forget to change this DB, right? Then you won't get the value.
Because if you change the DB first, only change that.
Yeah, that's the best practice, lah.
Because if I didn't change the DB, that means all the.
It can change. This one can change, no issue.
Oh, okay.
But it won't work. This DB also can work. This DB also can work. Both the DB can work. I mean, both the block. Because why? Because the first block is from the AI1. Try to use the DB. The second block is from the AI2. Try to use the same DB. Yeah? When both try to use the same DB, we'll have a value clash. So when PLC scanning, right, it will be like AI1 DB, AI2 DB is like this. Remember the first day or second day, you copy the timer, then forget, then it's cannot go to the
DB, yeah, the
same. Okay, good. Okay. Now what I want to do is, you already get the pressure, right? I want to do a simple program with the pressure. I don't need to change anything. Just use back the same program. Yes. I want to use this pressure, but we do the program in another FC lah. Because this FC is for scaling only. Okay. The program is very simple. Can I erase this? Q0.0 lah on output compressor lah. Okay, because I want to maintain the pressure. When I start the compressor will start on, right? On, the pressure increase. Then the compressor cut off. So compressor cut off, somebody use the pressure, of course the pressure decrease. Then on. Simple. So I will have a 2 set point cutting pressure. So must use a comparison. Yesterday you do the comparison, right? Use for compare, right?
Yeah. Okay, compare.
So cut off pressure. So I have a two set point. That is, let's say what is the range? We just now put 0 to 250. So yeah, if less than 200 can start, and on the compressor, if more or equal to 220 must off. Okay, this is the my set point. Now, how the flow works? Okay, so you need to add a start, stop, and one compressor. Your pressure you already have ready, right? Then this is a two set point. How? When I start, and when the current pressure, that is your pressure, when the current pressure is less than cut in, you on the compressor. Okay. Then if the current, so when you on the pressure increase, so when the current pressure more or equal to cut off, then the compressor off lah. Okay. And when compressor off, your pressure will increase by 1. So that is when compressor off. I go back to here the condition. That is when current pressure is less than 30, I on back. So I just keep on running until I stop. So when I stop, the compressor off. Okay, simple code.
No, but it will be a bug because if the compressor off but the pressure is still low, it will still start again.
That's right, that you need to do.
Or I just use the start for the switch.
No.
Yeah.
It's a push button. Try. Actually, you got the idea ready. Try. That's why to teach fresh graduates very easy for me because their mind is very fresh. They very fast they can catch. But if you work after 10 years, you come from this training are very hard to catch. Because there's so many things happening on the day. Then whenever I say suddenly pressure sensor, you try to imagine your pressure sensor. Oh, our pressure sensor is less than this. That our pressure sensor is a bar in 0 to 10 bar. Then your mind, you go to this bar.
Well, just now because I started with MD0, now I put I0.0, wouldn't it clash?
No, because M is memory, I is input. Different. Only thing you can use M0.0 you can use.
Huh?
M0.0 you can use.
Oh yeah, memory and input is different.
Yes. Pure, E&E, right? Not anything like specific, no. Just a electrical engineering.
They have 3, basically renewable energy, automation, basically what I choose. The one more is like telecommunication.
Okay. The one you choose?
Automation.
Automation, okay. then this one will be really tough.
there's not enough pressure, without pressing the start button, it should stop. It should start itself. But now, since I put it here, as long as I release the stop, then it will run again. Otherwise, it will be like run and then when it's high, you see pressure here. No, it won't. But it's like,
Okay, amen. This little modification can work. Okay. So your program is almost there. But this one is actually tricky program. It's actually very simple, but tricky, right? Go up. Okay. This one you take out first, but this is the one which is causing the problem, right? Delete first. Take out. Okay. Download. Okay. Now go reduce 200, less than 200 first. Okay. Now you start. And on right, because of this, you increase it a bit.
I think this one is the problem.
Yeah, no. You increase. Okay, it's off. Supposed to, not off, correct?
Supposed to until
Yeah. This one is put inside here.
or under here.
Yeah, no, beside here. Just drag, put it inside.
Or it's
Inside the latch. Because you need to understand that is this interlock is for my start button, not to cut off the compressor, right? Because that is when I start, I make sure the pressure. So means I start, I make sure the pressure is low, then only compressor. So if I put here compressor off, so I put outside.
no, but it also doesn't work like without the start button. When the pressure is now is low, like someone using the compressor, how do I activate it?
I need to press that button.
No, but surely it start itself when the pressure is lower than 200 and then
No.
I didn't press stop.
No, it won't start because unless I press start, then only can go.
Okay.
Because even though it's a low, right, the pressure is low, then only here is on. I wait until someone press start, then only I on.
No, I thought the program you said.
Repeat, right?
Yeah, repeat.
Repeat, because just now I deleted repeat. First we solve this issue first.
Oh, okay.
Okay, download, we test first. So, below 200, okay, so on, start. Okay, above 200, this one off, but compressor still run right until 220 task, right? Then go below 200 again. So you see here, below 200, this one is ready, right? Then go again, this one is ready, right? Right. So I need something in front that is make me to repeat. Correct. If I start again, I can on lah. Correct. So I cannot lah, of course. If I start again, means the condition is in front of this, I have something that is like can always on. You press the start button, you hold and you play. You hold that and you play with the value. Okay, when you increase, then you see cut off already. Cut off. Okay, decrease. Take on back. Right. Okay, it means if this signal here, which is if the signal is always on, after I press start, I can repeat. Right. So what I can do?
I Memory.
So when I press start,
Oh, you should activate the memory and the memory put inside here.
yes, correct.
Wait. So I use the set for the bar.
You can use a set or coil or something.
Oh,
It's up to you. Set network. Okay. Don't take the one. Maybe copy paste later when you change. Okay. Then what to one memory? Two already used. Bring it. Start and memory, yes, correct. You want to latch it or you want to set?
I think I should. Because if I set it, I have to reset it somewhere.
Latch also you do. Cut off. Okay, then put the start memory. Then this memory I put it here. Correct.
Yes.
Okay, then when I stop, I use the stop here. Same stop.
This one?
Yeah. Because when I stop, I want to cut off the compressor and also this memory. And now you go down. And now this one is just now you have some issue right there. Before start is already run. Right? Before earlier. Before you press the start button, when you decrease it's already run, right? Why? Because this one don't have a interlock here, means it's always compact. Correct? Okay. So now I can use the memory in front.
Oh yeah, I understand the problem.
Okay.
You see,
The
you're
problem
saying
is you go up. Earlier it was you add something here, right? That is down here also, right?
Yeah.
Okay. That is whenever it's
As long as it's lower.
as long as lower, before you start also you can run already, right? Why? Because this memory is on, right? Why this memory on? Because it's always comparing. So if I put the memory in front, when the memory is on, then only when I start, then only it will compact.
The start memory lah.
Yes.
Start of the memory.
Yes. So you can put it. You put it here in front. And make it simple. Okay, then put the memory. Okay, then you add a branch. Yes. Then you move this one to here. You just copy this. Call this. Double this.
Wait, can I see the pointer?
Sure.
Oh, yeah, okay.
The whole thing move here.
This whole thing?
Because this guy also need then can use the memory, right?
Oh, then I just save one that.
Actually nothing, no issue, but it doesn't look clear. So when the memory is on, if the pressure is low, I on this memory. If the pressure is high, I on this memory.
Oh, okay.
Then I can use this. So if I'm using this one, go up. There's so many things. If I'm using this, if I already put the interlock there, and I don't need this already. Here.
Oh, that means this one will open.
This one become the start. This one become the stop.
Yeah.
So many ways. but it's a bit tricky, right?
So when copy this and then I paste it inside my laptop, I can still open the whole thing, right?
Yeah. Can open and play lah. But if you want to on and off, make sure the address you change lah. The start stop addresses all you change to 1.0 or 2.0. The IW also cannot, you cannot key in because it's a physical input, right? So the best thing is like this one, right? This one. So when you want to test this one, your I0.0 all, say because this is your physical input address, all these change to I1.0 or 2.0, okay? The IW64, right, will change to MW. Then only you can key in the values. Because now I can
modify,
I can modify lah. Okay, now I get from the potential meter. Because IW64 I cannot modify. Okay.
IW64 is the analog input.
Analog input. You cannot key in, but it's from the output. I mean from the outside lah. Okay.
And what I do? Memory?
Memory is in the inside only, so I can key in any number.
Oh, okay.
So let's say you just assume lah, okay, it's already reached 50%, so you key 13,000. Then you can get some value. But if you are working with the factory I/O, then you can use the IW. Because factory I/O can link the IW.
Oh, they also have like pressure sensor.
Not pressure sensor, they have like a level meter or like some analog. So even you can use MW or IW but other numbers. You know, IW 30 or something. Which is not, because this is your AI, physical.
Go lunch.
Okay, it's good for lunch.
See you later.
Just double check your name and I see. Then tomorrow around 12 p.m. whether you will receive the digital copy of the cert. And then by Shopee voucher code about 50 ringgit. So if you're looking for other type of software or any other type of video courses which we have, plenty of it. Not only Siemens which she also got, Omron also got, and what else? Including SIMATIC Manager also got. Omron also we have. So, yeah, tomorrow you receive the link, then you receive the voucher code. So if you want to get other type of software also you can get from there. Siemens TI portal is completely free. Your laptop already installed, right?
Yeah.
And then should be okay.
I mean the videos free?
The video tutorial, you can use the 15 gig voucher. Just get it to Shopee because 15 gig. So you can get it whatever video course you want. Including TI portal also we have to Shopee. Completely free because you're going to use the voucher. Once you order ready, I just share you the cloud link. You can download all the video. In return, all I ask is give me the review.
Oh, okay.
Yeah, alright.
I think I see it.
Win-win situation.
Name.
Name I see okay? Alright. And then I'll pass it to you tomorrow. How you find this training so far?
Huh?
How you find this training so far?
Yeah, that is quite effective.
Quite effective. One time training, sometimes we get 2 packs, sometimes maximum we can handle 6 packs. Some clients say one-to-one is okay. Some clients they love to they prefer to study in group. So for you, one-to-one still okay.
One.
Still effective. So at the end of the training, consultation is completely free. So you can contact Mr. Given anytime if you need any help in your project or whatever. Okay. Keep in touch. Because you only must be careful. I'm not gonna let you. Make sure you practice. Most important thing is practice. Must practice. If you don't practice, you end up like me to do everything. I have no time because everything the management, marketing, all that. So he's the only one who handle the programming. I handle all the IT side. Okay.
Now we do a global DB. Okay, then we can do a SCADA, then we can see how to do trending. Okay, we use the same project. First thing is add new block. Data block. Global DB, okay. And the name of the DB, okay, DB, because all the data we want to put in as SCADA, just put SCADA. Okay. So this DB will be empty, okay, correct? Because not using this DB cell, this DB will be empty. Okay. So what we want to put in as SCADA, okay, what we do is let's say what we do is this one, start, stop, compressor we can use like this one, because when we want to put one button in HMI, right, we will be using memory, correct? So but I don't want to use memory, I want to use the SCADA. So the DB, yeah. I want to put the start, stop, two set points, cut in pressure, cut off pressure, then the pressure value. Okay. We do for this lah. Okay. So you put start, stop. Start, stop. Okay. Then pressure. Pressure is an integer, right? Okay. Then
No, the pressure is in
real, is it?
real.
It is real.
No, actually there's two types. Real and integer.
But your program is using what? You go to the compressor. Go down. Okay. Real lah. Because I already used this one. Use real. Not that it is right. Then cut in pressure, cut off pressure. Okay. Then we go to the compressor. So for start button you add, and stop button also you add the DB.
Add the DB.
Yeah, like a memory, you know, the start. Want to open? So normally what we do, we use a memory, right? You don't put DB, just put SCADA. Yeah. Dot. Yeah. Start. Yeah. Then normally close. No, this side. Because I want to cut off this one. Normally close it means series.
Yeah.
Okay, yeah, start. Okay, next, go up. This copy this. Go up. Okay, add here also. Then go to the scaling. Okay, so now we don't want to disturb lah, right? You want to use this one, right? Here, this is the one, right? Here use it. Okay. To delete that, use the DB. SCADA pressure and SCADA tracking.
This one and this one.
Yeah. Kat ini ya. Save. So I'm using all the DB because later in the HMI I just focus on the DB only. Because if I see in the PLC tab, I will have so many. Correct? Okay. Then you go to tag, show all tag. You will take up this one. Okay. Pressure real. Not using, right? Just remove. Okay, save. Okay, go back to the compressor. So this one no address going on. Okay, because I'm using a DB, right? Okay. If I want to use Siemens HMI or Siemens SCADA, I don't need the address. Okay, you know why? Because when you, how we do the button, when we put the button, we go to event and we choose press, right? Then we choose set bit, then we choose the memory, right? Okay, like start HMI, stop HMI. But now I need to choose from the DB. Okay, because if I do Siemens HMI or Siemens SCADA, I will be doing in the same project file. So I can access to this DB. But if let's say I'm using a different HMI or different SCADA, I need the address. Right. Okay. So if I want to use the address, you right click the SCADA DB. Properties. Okay. Under attributes, optimize. Uncheck the optimize.
This one?
Yes. Okay. Okay, click it. So I will get the address. But now question mark. So after I optimize, I need to compile. Yep. Okay, click that also can, and right click compile also. Now I get the address. Okay, we go up. Okay, you see this one is a DB5 is your DB. DBX means it's a boolean 0.0, 0.1. Right? The next, go down. Can you see next automatically become DBD because it's a real, right? Like MD, MW, DBD2, right? But actually they can use DBD1 also, correct? Because they just use 0.0, 0.1. So the byte one is still available. Okay, never mind. You go to the DB. You see, the start stop will only use 0.0, 0.1 only. Right? So, of course, if I want to use a byte, I cannot use the byte 0. Byte 1 is available. Right? But when I choose real, can you see it automatically become true? Because the software itself works in that way. Okay? But what is the advantage of using this DB instead of using memory? Okay, I can do the same thing in the memory one. Correct? This one may be M20.0, M20.1, MD22, MD26, MD30. Okay, but can you see I have a function called retain? Okay, if I enable this, if I key in any value from the HMI for the cutting pressure, cut-off pressure, right? Because now I need to key in. Earlier you use a constant number, right? 200, 220, constant number. So whenever you power off and on, the value will be there. Okay? But if I change the constant number into M, memory, if I power off and on, the value becomes 0. or even I stop the PLC, stop and run, the value becomes 0. Okay, that's how the memory works.
Okay.
M memory. Okay,
So like here,
I can
because
use
I enter the
MD.
value just now, right?
and just now like you enter the constant number, right?
Yeah.
You can use that way, or let's say you want to key in the HMI, I can use MD also, correct? But MD, you can key in, the value will go to the PLC. Then it can work, no issue. But the moment you stop the PLC or you power off the PLC, the value will go off, become 0. Okay? So to retain the value, to keep the value, I must use DB and I must choose retain. Yes, retain on. Yeah. Oh. Okay? It means let's say today I click 200, suddenly power off, then I on again, the value 200 will be there. So that is the reason for the HMI. That day we use for HMI, right? HMI also can use DB. Because today we haven't learned DB, that's why I use a memory. Like, means you have an option, you can use a memory or DB also. But memory, what is the disadvantage of memory is you cannot keep the value. Let's say the value is not important, for example, okay? But memory means that you need to know which memory is available, right? Because you use some MD, M0, all that, right? So you need to know which memory is available. And sometimes you might skip the memory because all the boolean maybe 0.0, 0.1, then suddenly become MD 200, 204, like that, okay? So you need to know, to search, right? If DB means whatever you want to put in your SCADA, you can put in one DB. So you can arrange your program nicely. Okay, that is the function of DB. Other PLCs don't have this.
Other PLC don't have.
Other PLCs don't have this like this function, data one functions.
Really? Only Siemens?
Only Siemens.
Oh, okay.
Other PLC, they give you a memory, you must use this memory. So they give you a range of memory, you must use that memory. Okay? Okay, save. Save, download. Go back to the compressor, monitor, okay, just key some value here, what is starting 200, okay, then this one is at 220, okay, so the value always will be there. Okay, you stop the PLC, here, on right hand side. Right hand side. Go.
Huh?
Right hand side. Yeah.
Oh.
Okay. Okay, run. Okay. See, the value is there. Okay. We just change this one example. I don't need to catch out this one. Go to wash table. Down here. You just add address here, maybe MD20 or MW20, any number which is not using. Okay, change to decimal. Monitor first.
Oh.
Okay, modify some value.
Yeah.
This side. Yeah. Any number. Okay, enter. Then you modify. Take this one. Modify. Here.
Where?
Here.
Oh. Modify also the values.
Yep. So the value we keep go to the MD20, right?
Okay.
Okay, now the MD20 got some value, right? Okay, you stop and in the DP also need to select, you know. The written need to select. Okay, it's not by default it can be written. Some PLC, what happen is this, right? So they will give you like, for example, like Omron or Mitsubishi, they use D. They call data register. Because for Boolean, they have a different one. Because memory, right? This memory, you can use as a Boolean also can, as a word double it also can, right? But most of other PLCs, Boolean is different. Okay, that's for Mitsubishi. Boolean is M0, M1, M2, okay? If for values, they call data register. They have a D. Okay, D0 maybe until D8000, something like that. Okay, they have. So the same D you can use as a word or double word. Okay. Now, the D, they give you a range, right? Not all the D can keep the value. Okay, same like this. Okay, key in, power off and on, the value will come. So when you go to the manual, they say, let's say for example, Mitsubishi, the small one, as I remember, the D address they have the small, very small one, from D0 until D2999, 3000 data registers. Okay. From 511 until 500 something, only can use as a retainable memory. Only that particular D only can keep the value. The other D all same like this. Okay, okay. So they have two different, the same data. They have some data can keep, some data cannot keep. And Siemens, okay, memory cannot keep, data register, data block. Okay, okay. Now go offline, we do the SCADA. Just click. No, just click anywhere here, anywhere. Okay, then go offline. Okay, now go to add new device. PC system. Okay, if you're using Siemens PC, then you need to choose the industrial PC. Okay, then SIMATIC box PC. Then you need to choose which model you are using. Okay, but we are using a normal PC, right? So we choose PC general, PC station. Okay, now at the right hand side here, you add a communication module, because between your laptop and the PLC is a Profinet, right? Okay, Profinet, and you use the general, the last one. Yes, because it's a normal one. Okay, it's follow your laptop. If it is you're using Siemens one, then you need to choose the which module you're using, which cables, which communication. Okay. IT general, drag. Where is the blue color? You need it. Okay. Then go back to the right side. Now you can add a SIMATIC HMI application. Okay, so you can use advanced or professional. Okay. Advanced is like a SCADA also. But it's like the number of tags I can use is very less tags. Okay, professional means they are WinCC, the Explorer. Okay, but we use the advanced. Why? Because our laptops don't have professional license. You can do, but you cannot open it. Okay, so we use the runtime advanced. Right? Yeah, it's the same thing. Just the number of tagging I can use more in the profession. Like around I think 65,000 tags I use. More than that. But the license also will be different, when you want to buy the license based on number of tags you want to use. Let's say you want to use, I think the lowest is not mistaken 512 tag. Tagging means 1 one button is 1 lamp. One lamp is 1 lamp. So 5.2 tab, then 1024, 2000, 655. I think more than that also. Okay. So we choose our PC station, choose Ethernet on Ethernet port and WinCC add-ons. Okay. Go back to here. Yes, yes. Then you connect between your PLC HMI. Yep. Okay. Save. Now go to the HMI runtime. Go to WinCC runtime. It works. Okay. Go to the screens. Add new screen. Double click. Now you have so many functions. In SCADA, you will have like pictures of pipe, all that. Here, like as a one. Here we have like a pipe, piping, the L shape, the T shape pipes. It's not a pipe; it's like a shape, okay. But you can get from here also the pipe pictures. Here, symbol library. Okay, symbol library is you can get the pictures of the motor, pump, all that, and you can change colors. Okay. Okay. Now what
I said SCADA, there's like different shapes and stuff. How much is now SCADA?
This one you can get from here the pictures. Okay, like this, right? Because HMI don't have this, right? HMI don't have the symbol library. Okay, HMI, if you want to put a picture, you must go to the graphics here. You must go to the graphics here. Okay, then these graphics can change colors. But here got so many. Go to properties. Okay, bring this one up. Okay, then you can choose which one you want. So many, then pump, here also can choose so many things.
There's no
Compressor.
compressor.
Compressor normally like motor lah. Compressor motor. Just choose anything. Okay. Okay. Then, okay, you see, if you want to change color of this, what you do? Go to the animation, right? It's the same thing also. Okay. Go to appearance. You add here. Yes. Then this one is a compressor, so you need to choose from the PLC tag. usual. Okay, wait. You add another one first. Now you will just remember this background and foreground color. Now go back to the property. If you want to change the color property, go to appearance. You see you can't change the colors, right? Because it's the original state. Okay. This is one of the differences also. If you're using the professional can change color in the original state. Okay. Now we are using the advanced. Advanced also can, but I need to choose to shade it. Okay. You see here, shaded what color I can change? Foreground color. Because no background. Because background is transparent. Okay. So remember foreground color. So go to animation. So if you want to change the color, you must play with the foreground color, not the background color. Because for the shapes, it's a background color. But because for the shape, they will have a background and border, right? For the pictures, they have a background and foreground color. So background, you choose transparent, so you must use the foreground color. Okay. So then buttons. Same. And if you choose professional, in professional you will have a round buttons, round and square buttons. I don't want to add one more professional, so cannot open this. Okay. Start. Okay. So start normally what we do?
Events.
Okay. Press release. Okay, type also you know, set it. If you know the function, right, you can type. Okay. Now here, I need to choose from where? No, because we created the DB, right? Choose from the DB. Yes. SCADA DB. Okay, start. So if you want to change the color of the button, right, it's the same thing, animation.
This one also.
Yes.
This one also go to.
Same. Now you can choose from the HMI tab actually. Go to the HMI tab, go down, open, HMI tab, okay. Because when you choose right, it will automatically go inside here. Now you see the grey color is which one? The background, right? So you must play the background color. No, don't put grey color. Put green color. No, when it's off, because when it's off, it looks like start, but it looks like grey color. When you press, then only it will on, right? Put a dark green one. Dark green, yes.
Wait, why? I don't understand why.
No, why? Because when you put a button in the HMI rack, normally, start button what color will it be? Green, right? So, but before I press, the button is already in off state. But if you put red color, they will, confuse me. Why red color?
No.
But if you want to put for your status, there's a difference. This one now is a button, right? But for this is a status to show that is on, right? So put green color, red and green lah. Okay? But sometimes it's different, some company style is different. What they do is, if it is in standby mode, means if it is not running, they put green color. When it's running, they put red color. Because some of my participants, when I ask them to design, they do design like that. And I ask why? No, they say this is out their system also. For their system, when the motor is not running, is it green color means it's okay. It's healthy, it's standby. When it's running means they put red color. Means it's running. So standard color is normally what we do is if it is not running, red, when it's running is green. So colors depend on. Okay. Then you do for the start ready, stop. Then you must put 3 values lah. The I/O field lah, right? 3. One is the current pressure, cut-in pressure, cut-off pressure. 3 value key. Yeah, the I/O field.
This one?
Yes. Later lah. means it's not communicating lah. Okay? Okay. Forget to change to so, full window. You press the window button and you close the runtime. Right click close. Okay, yeah. Go to runtime setting. Down here, on the left hand side. Runtime setting. Full screen mode off. The full screen mode. Okay. Save. Okay. Now again, you click on the HMI. Yes. Go to runtime. Online runtime. You can use this also. Yes. Wait. Okay. Cannot communicate. No, cannot communicate. Okay, let me close minimize. Okay, so if you cannot communicate, the first thing I need to see the communication. Okay. Go to connection. Go down. Okay, open the runtime. HMI RT is runtime. Okay, go to connection. Go up. Yeah. Okay, it's connected. HMI. Okay, so it's okay. Then you go here. Search here. Control panel. Set BGPC interface here. Yes. Okay. It's internet connection. Okay. So not an issue. Okay. So that's okay. You close. Okay. Go to on the left hand side. Go to your PLC. Go up. Go up. Okay. Click on your PLC and go online.
And download.
No need to download. Go online first.
Maybe I do something wrong with the.
No. Nothing. Click here. Right click. Properties. Go to general. That's correct. Go back to the runtime. Go down here. Go down here.
Oh.
This is called runtime.
Okay.
Because I only have this thing. Okay. I know why. You disconnect your HMI. Then you disconnect. Disconnect from that.
From here.
Yeah, from the HMI. Click the start. Stop. Go offline. Click the PLC, go offline. Choose the PLC, go offline. Then go to device and networks.
E5. Oh.
Maybe the IP address now. Click here, like a spec. Yeah.
Show.
What's your laptop IP address?
Should be 10.
Change it to 10.
Change to 10.
Okay, save.
Yeah.
Yeah. Okay, another thing I want to know, that is save, and right click the PLC, properties, go to protection, connection mechanism, only allow, okay,
This one.
no, must uncheck lah, okay. So what I do, okay, never mind. We already changed the IP address. I will test the IP address first. If no, I want to re-download the hardware configuration form. Okay, maybe I'm not sure. Maybe because of the previous setting of it, it's not allowed to communicate. Okay. Okay, what we do? Go to the advanced runtime advanced. Go down. Click on the yes. Click the runtime.
Click the one.
Here. Yes. Wait. Okay. Never mind. Don't close. Minimize. Okay. You go up. Left hand side. You go up. Choose the PLC. Right click. Download hardware configuration. Download to device hardware configuration. Yes.
Load.
Look. You check your runtime, is it okay? Go down. That's settings.
Like how again?
Where is
Just
it?
go into
The setting. Right click here, not about the IPHA. So right click here, go to properties. Okay, this setting, okay, what happens is, whenever we download, right, first time download, right, okay, so this one go to the default settings, like keep inside the PLC, okay. So whenever we download, we only download the software, okay, not the hardware configuration. When we do the first time we download, right, so only download the programs. So the hardware inside and our setting is different. Okay. So what happened? I check here. You already unticked. It's alright. And you create a program. Okay. So I ask you to download because inside the PLC is ticked. That's why you cannot communicate. Your PLC cannot communicate to normal laptop. Only can communicate to secure communication. So once I download this hardware configuration, then it can communicate. So that's the issue. So normal. Okay, go to runtime. Start. Yes. Then you can decrease. designing is similar like HMI, right?
Mm.
Okay, only the some settings lah, okay. What I want to do is now close this one, close the runtime, close runtime. Yes, this is for runtime. Go to your runtime here on the left hand side. Go down. Go to your runtime. Okay, go to screens. Add new screen. You name the screen as trending. Right click, rename it. Trend. The graph. Okay. Then screen 1 change the name to main. Add a button down here or top anywhere. Okay, this button I want to use to change the screens. Okay, so this is in the trending page. Okay, you put name main. Go to property. Properties.
Oh, right click property.
Go to event. So when you press, what you want to do? Change the screen, right? Okay. Activate screen. Okay. Then the screen name is what?
Main.
Yep. Okay. That's all. Then go back to the main screen. That's all. Press only enough. Okay. Go to the main screen. Do the same thing. Add one button. And when I click activate, go to the trending. Okay. Close this. We add trending. Go to the trending screen. You add a trending. You take this trending on the right side. So, drag and up. Properties. Go to property. So what you want to trend here? Pressure. So put a name, pressure. Okay, the style. Okay, use the style. Okay, the trend view. Okay, means the view here. How many trends you want to do? Okay, 100. Okay. Okay, then the trend type is how? Here. Cyclical real time means follow the time up. It will show the trending. Okay. Choose the cyclical real time. Then the source. Which one you want to trend? Your pressure. Yes. So every 1 second you want to show, or this one you can follow lah. Okay, back. Okay, okay. The size, the style, the color you change here. Because it's black color, black color you change. You put some interpolated with the line. Okay. So red color, red or solid line. Okay. The line width also you can do. Then the rest is the normal settings. Okay. Go down. Then the axis, okay, left value axis, Because ours is 0 to 250, right? Okay, put 0 to 250. Because you can see it show only 0 to 100. Then on the right hand side, say 0 to 200. Okay, then so many settings you can do. Time axis, click the time axis. Time axis is the X one. Okay, 100 is okay. Increment is 5, okay. The left axis, go to the left axis. Okay, show help line. Actually, going the help line is okay, you go down here. No, you can go down. No, okay. Here, yes. Stop. Okay. You enable show help line. This is the line. Something to for your reference or something you want to keep, you can keep. Let's say you want to keep at 200 or 220. I think about this. Okay, that's all. Okay. In the same graph, I can add multiple lines, that is under here trend. So the more you add, the more line you can see. Then you can put different colors. Okay, save, test. Okay, good. Any question on the DB and SCADA on that? Okay. So they now you know the function of the global DB. Okay. One is able to keep the value. One is like you can dedicate one DB for do this job. You know, for SCADA, whatever you want to show here. Later on, let's say for big SCADA is you've got so many buttons, so many values, all that you can key in your DB. So anything you troubleshoot, you just go to the DB and check. Okay. Can this one is okay, no issue. Then can close. Save. Save project. Then you create a new project.
Save it.
Because I don't want to HMI.
Oh.
There is new.
Actually, can take out.
So this is a induction motor. Okay, AC motor lah. Okay, and this is the motor plate. The what you call the motor lah. Okay, how many amps, how many RPM, okay. Then this is the inverter. Okay, the variable frequency drive. But Siemens this model lah, this model got 3 parts. So we have a power module. This is the power module. This is to control the drive, the motor. Okay. And this one based on the size of the motor. Lah. How many kilowatt?
Okay.
How many kilowatt is the motor? And you must buy that according to that. Lah. What I did just buy a 0.55 kilowatt motor. I mean the drive. So the drive can control up to 0.55 kilowatt. But my motor is just a 1.8 kilowatt. 0.18 kilowatt. Means under 80 watt only. But this one can go up to 500, 550 watt. Okay. Then this one is the control unit. This is the one get the main signal from the PLCs or that. Or you can use hardwiring. You can use Ethernet to communicate between PLC to here, or you do hardwiring. This one also got input outputs. Some digital input to control on, off, forward, backward, stop, everything. Some analog input output for the to control the speeds. You know, remember just morning we did we set the speed 50 hertz. Then you measure right the output. The output you connect here, then you motor can run 50 hertz. Okay, but we want to use Ethernet communication. Okay. Some modules together. If you see the blue color motor, right? It's together. Means the control and the power is together. Some module, the white color is relevant. So that one is a small one. So that one is the same. It's together. It's like one set lah normally lah.
Can be separated.
Can be separated. Normally one set. What happens? Siemens what they do? They have this one only one design. Okay, because this one is a for Profinet. Okay, if you have a bigger motor, then you just buy a new one, bigger one. Sometimes the size is very big, high kilowatt, like 4 kilowatt drive for this big. The drive, the power, the control unit is
It's the same lah. It's can be used for others.
this can be used for other models also. Because I have two. There's another one, you see, down the right. So because this is a PN Profinet, which is design cable. That one is DP. DP. This is the Profibus cable. Then this is they call BOP. BOP, Basic Operating Panel. There's another one called Advanced Operating Panel. The one with more functions. It's you copy the program or the this one just key in the data or save only lah. Now you see this one got a bus fault. Bus fault means communication error. Means why communication error? Because inside here already have program from previous training lah. Okay, they already programmed this to run with this PLC. Okay, now I connect. Now it can recognize the PLC. Because inside the PLC, I don't have this program. Once in the PLC, I add this module and I download the program to that, then it can communicate, right? Then it will be ready. Okay? But this one we can just click the end auto and right. Then we increase the RPM. Just to check the settings all of you. Okay. And we can add this in our PLC. Then we can do program first. So I need to remove the end auto.
What is end auto?
End auto means I test here. End auto I test here means I only can test here. The PLC can do this. So once I done, I need to then I need the PLC. Error. Now only the pass fault lah. Communication error. First we add this one. So go to add new device. Drives. Okay. Dynamic G120. Okay, control unit. So means I'm adding the top one first. Okay. So the model I'm using is a CU250S PN vector. So yes. Wait. And the version is 4.7.10. How to know? Same thing. I need to upload this one back up. Okay. But this one only to use like as HMI we use yesterday the Pro Save, right? To upload, right? So this one can use their button to upload. Then I can know what is the version. Okay. Okay. That's the top one. Then the bottom one is the power unit. Can you see power unit? Power unit is the bottom one. Okay. That one is I'm using the PM240-. Then is I'm using a single phase. One is C. My model is under FSA. First one, second one. Okay, second model. Yes, this is the model I'm using. If you check the part number, you can. It's 200 volt, 0.55 kilowatt. Okay. Then once I add here, go back to here. Check. Here. Then connect between these two. So it will create a Profinet IO system. Okay. So if I have 10 motors, same. I do it then. So I should connect.
From PLC.
Yes. Okay. You click on the IP address. Okay. Here. The spec here. Top.
Oh.
Yes. So by default PLC is 1, drive is 2. Okay. We leave it 2 lah. Okay, because I disconnect the HMI already, right? So we leave it 2. Because if I still connect, then it will have a conflict because the HMI also. So later once we add, it will switch. Okay. So it's okay. Let's see. Now you click on the PLC, right click. So wait up. So like I said, the drive already have the program, correct, from the previous one, but still got error, right? Because why cannot communicate? Okay. What I do now to the PLC Profinet system, I already add a drive. So I right click the PLC, download the hardware configuration. PLC drive on that thing. Look. Okay, look. Already, right? Because why? Because now is the drive is connected to the HMI PLC already. Okay. So later we can do the drive the settings all, then we can what? We can program it. Okay. Before that, what we do? Double click the drive. Okay. Click the drive. Here. Right click properties. Can I use this?
Yeah.
Go to the Telegram configuration. Okay. Then drive.
Move up.
Yeah, okay. Enough. So send means okay. From the drive to the PLC lah. Okay, means the feedback I get from the drive. So and the PLC is an input I, right? Okay. So once you do the settings connection, right? Okay. Therefore standard telegram click here. Therefore few standard telegram 1, 2, 3, 4, okay. Therefore meaning. It means how many data you want to take from the drive, how many data you want to send to the drive. Okay. If I choose standard telegram 1, it means I send 2 data to the drive, 2 data I get. Okay. If I choose 2, I think 4 data, 4 data. So each one they have a meaning lah. Okay, later we see. Why I choose 2? I mean standard telegram 1. Just put 1. It means I'm using 2 slot. Okay. PZT means is a okay. At drive they call PZD lah. It's called processed data in German. PZD, processed data.
Yes,
Okay.
I think process because
Z.
Z is process is spelled with Z.
Z, yes, okay. So it's a 2 word. At the PLC is either I256. Okay, and they say 2 word, right? It means IW256 and IW258 because they say word. Okay? Same goes for your receive also. Click on the receive. Receive means from the PLC I send to the drive. Okay? So this also same. I use a standard telegram 1. Okay? So I send 2 data. Start with QW. So output QW256 and QW258. Okay? So when you go to the manual, right? When you go to the hardware manual and check what is standard telegram 1, okay, they say 2 input and 2 output lah. Then you go deeper, what is the first input, what is the second input. Okay. For this one is they call status word. Okay, means status means what is the status of the drive, whether it's running forward, running backward, error or standby. Okay, 1 word only, but they can give that 4 stages, 4 many stages also. Okay, how? Because 1 word I have how many bits? 16 bits, right? So what happens? Let's say forward, right? Forward means 1 value, backward means 1 value, like that. So later we can test what is the value. Okay. Then second one is the they call actual speed. I'm using the same name from the manual. Okay. Actual speed means what is the current speed. Okay. Here this one they call control word. Okay, and this one they call speed word. So control word means you control forward, backward, stop, reset, everything. Speed means you set the speed lah. Okay. First we see the speed word. Okay, when you go to the manual, what they say is if you want to run maximum speed, okay, the range is 0 to 4000. Like an analog lah. Okay, 0 to 4000. It means when you set like an analog output, you remember just now we do the analog output, right? And then if you send 27,000 to the output and you connect the wiring to the drive can run 50 hertz, right? The same concept. When you send 4,000 to this address, the motor can run full speed. But 4,000 hexadecimal. According to the manual, normally any manuals, I mean drive manuals mostly lah, they use hexadecimal numbers. Okay, but it's up to you. You want to use hexadecimal or you want to convert to decimal when you do the scaling. Scaling.
Scale.
Yes, because these numbers nobody will understand, correct? We only can understand the RPM or in hertz. So you key in hertz, 50 hertz, then scale to 0 to 4000 hexa. Or you want to change to decimal 0 to 16,384. Okay, so you can send this number also, can send this number also. Okay, so when you send, and you need to control, you want to forward, backward, all that, right? Forward, backward, stop, and if you get any alarm, you reset. How it works? Means 4 data but 1 word. Same like this concept. Means if you set one value, it means it will run forward. If you set, let's say for example, if you set 10, 10 means sum of the bit is on, right? Sum of the bit. Because it's a word, right? So if I put 10, sum of the bit is on. So that particular bit, it meaning, because later in the table I can show you all the 16 bit, what is the meaning. Okay, so sum of the bit on means okay, it is forward. Then if you want to stop, okay, let's say you put 25, sum of the bit is on. So when you send this value to here, then this one got 16 bit, sum of the bit is on and off. So the drive will know okay, this command is to stop. Something like that. Okay, so each one they have different numbers. So when you go to the manual and go to the control word, under control word they will give all the 16 bit what is the meaning. Then you, according to that you arrange, okay, this one when I want to forward, okay, it must be forward on, set point enable, clear the alarm, okay, this one, when you put 11001111, get some value. That value in hexadecimal also. So normally Siemens drive, they show it as decimals. Okay. So if you want to run forward, the number is 47F in hexadecimal. Okay. So means if you send this number to this word, the motor will run forward. Okay. C7F 47E 4FE. So these are the numbers. Okay. Later we can see the binary how it works. Okay. But it's in hexadecimal. So another one. I forget. Because this is where we're going to use a lot of move function. So it's up to you. You want to use this number or you want to use the hexadecimal number. So hexadecimal or decimal number lah. So decimal number, this one remember, these two here, 1150 and 1151. In decimal if you convert. Okay. But at the end it's going to be in binary lah. Okay. Then same. When this one running, let's say lah, I set 4000 and I put forward. So when this one running, forward, backward, standby. Forget the number. But this one later check lah. Okay, because I think it's an AF37, EF37, and this one forget. Okay, but L11 we can check. So the actual speed will be the same thing lah. Right, so it's a 0 to 4000 hexadecimal. So that is the function. If I choose standard telegram 2, means I will have another 2 data here, another 2 data here. Or sometimes what happen, output is only 2 data, but the input I can get multiple data. Temperature, what is it, torque, everything. Okay, good. Then the programming is very straightforward. Programming is this one need to do scaling. I set 50 Hz, convert to 16,384, send to this address. Then at this address, I send this value to this address. For that, I need to use move function. I send this number to this address, then the motor can run forward. Okay? Any question until here? Wow. Okay. The thing is, I know because we haven't tested, so we cannot fully, go into it. But okay, this is how it works. So any drive you're using, same thing. Okay. Another thing I want to show you, I want to tell you, Siemens not only can control Siemens drive, some other drives also can. Okay, but make sure some other models can support Profinet. If you can support Profinet, what you can do is go here, then bring it down. Okay, so if you can let's say that you have another drive, another model, right? Then let's say ABB or some other models. Okay, you need to go to their website. You need to download GSD file. GSD called General Software Description file. Okay, that file you need to install here. Go to tools, or option. Go to option. There is manage general station description. Okay. Okay. So what happens is, let's say for example, they give you task. Okay. The Siemens drive I want to connect to this Mitsubishi PLC, Mitsubishi drive. Okay. But they need to, you go to the manual, you can check whether this one can support Profit or not. If it can support, you go to Mitsubishi manual, the page, go and look for the part number and put in Profinet GSD. Okay, you can download to your website, to your laptop, then you can go to here and install. After install, I can get from here. Because under here, okay, just now we add new device from here, right? Okay, from here. Actually, this Dynamic, right, I can add from here also. Go to the drives, Dynamic drive, Dynamic G. Yes, I can add from here also. Okay, okay. But we close the drive. Okay, that's it. I already installed the GSD file. Okay, go to other field device, Profinet IO, drives. Yes, it will show here. Means in this laptop, previously I have installed this Bosch brand VFD and Mitsubishi VFD. Okay, so same thing. I just drag and put it here, set the IP address. Then for that also the same thing. I need to choose the Telegram. Means still you need to go to their manual and check lah. So the Telegram, okay. How many data they can give, how many data I can send. Normally the main one basic is the two lah. And two data I send, two data I receive. One is to control forward, backward, all that. One is to control the speed.
All this hex up is moving the numbers is found in manual.
Yeah, but the thing is, in Dynamic manual, they won't give this number. They will show only the 16-bit data only.
16-bit which one?
No, inside here got 16-bit, right?
16-bit.
Yeah, QW.
Oh, I mean QW.
Means Q25610 until Q257.7, 16 bits inside. Right. So they will tell you, okay, bit number 1 is what is the meaning, bit number 2 what is the meaning. So if you want to run forward, okay, bit number 1, number 2, number 5, number 10, number 11 must come. Something like that. So when you send this number, it will go in a binary, right? Binary, so it will become like Then you can run for. So in SIMATIC manual, they don't give this number. Okay, in SIMATIC manual, they just show you in a table what is the bits. Where I get this one I get from the MicroMaster manual, the old Siemens. There's another Siemens drive at the back.
And also just
It's the same thing.
Okay,
Same thing. Yes. Because I see in SIMATIC they don't have this. When I go to Google, they say the same number, right? But I know the MicroMaster is this number because I worked there before. Because normally MicroMaster I use the S7-1200 lah. Okay. Then I go to their manual and I check the MicroMaster, the 16-bit. This one, right? The 16-bit and the SIMATIC 16-bit the same or not? And I see it's the same thing. The distribution of everything is same. So I use the same number. Okay. And one good thing about this all the PLCs, okay, whatever it is, I already added the Mitsubishi something like. If I add here also I can choose how many data I want to send, how many data I want to receive. Okay. The value, this one is a bit different, but this one is the same thing. The speed setting, the range is always same. Because why? Because they are using Profinet system. Means in the Mitsubishi they already add this Profinet coding inside them. So they use the same. This one, some drive used similar to Siemens. Some drive no. Some drive you go and need to check the bit. Then you need to know which bit. If you are not run forward, which bit need to on. Then only you can send forward. Okay, yeah. So we take a break, and after the break, we go to the manual and see what is this one, all that. Then you can clear your mind.
I change it to a memory like MW something,
Mm.
MW60 or something, or I change it to like something that is not physical address for factory I/O.
For factory I/O.
Yeah.
No, if factory I/O, you can see. Okay, I show you. If you want to use in factory I/O, right? You follow the factory I/O first. Where's the factory I/O? It's not open. Is it?
No, it's not open. I'm trying to like write something down, like notes,
Yeah, okay.
so that I
So
can remember.
in factory I/O, right? Remember, you will do the configuration, correct? In factory I/O, you can do configuration, then you can select how many input, how many output, right? So when you do that, how many input, how many output, and below that, what word or double word you can use. So you can choose want to start from what number, 30 or 40. They are automatically by 30. No, then the best thing is what you do is when you want to do programming for factory I/O, you design first.
Design the program.
Design the program. No, design the graphics.
Setup, okay.
Graphics, everything. Then you list down all the I/O first. How many digital input, digital output?
Just like what we did usually lah.
Yes. How many analog input, analog output. Okay. Then normally in factory I/O, the values right, like potential, the level, all that are normally will be in float. But you can see the color
We want to
in real.
real.
In real, normally in factory I/O, the values are sometimes will be in real or sometimes will be in integer. But you can see the color. Okay, how is the color? Okay.
But what it means, like after I create something, like input, and then I will see a flow thing.
It's like this. You remember in the one when you do the driver, right? Okay, you must add all these,
Yes, yes.
right? The start, stop, all that. Okay. Let's say tank level, right? Then there will be a box or something like here, something. You should see the color. This color down there they will show. Okay, integer. Okay, black color. So example, float is blue color or something like this. They will give you. Okay. And now, when because you can choose, right, how many input, how many output you want. Correct. Okay. So the first thing is you design your system. Then on the left hand side you will have all the input. On the right hand side, or you will have all the output, right? Okay. Then you calculate how many input, output you want. You go to the settings. Okay. Once you do setting, here you will get the inputs. Then for output, normally by default, it will, for analog, it will be IW30. Normally standard, you start with 30, 32, 34. If you choose double, it will show ID30, ID34, and so on. Okay. You design, then you use this number for programming.
I thought you said like 0.0 I cannot use. Oh wait, I can use.
Can. For factory I/O can use.
Oh,
That's what I said, for factory I/O can use. Let's say if you are not using factory I/O, you want to test within the PLC. I say you create a HMI, then you create a simple program, you want to play around. That one don't use I0.0 because you cannot modify to 1. Modify to 0.
okay.
Because for factory I/O, I can use 0.0, which is similar to my hardware. Why? Because that's why they already do the program. You know the FC9000, they already do the program ready for you. The best thing is you create
So C first.
this one. You do this first, then from here I can get the address. Then I do in my program.
Then I can test one by one.
Yeah. Normally what I do, because Because last time I used to do videos, you know.
Videos?
During COVID time, no training, right? So he asked me to do Udemy. Have you heard of Udemy?
What is it? Udemy?
Udemy.
Udemy?
UDEMY is like online platform. So they sell online courses. Okay. So online courses is like this one like a full course lah. Example lah. Teach all these hardware configuration everything. I make into a video. Okay, like 10 hours, 12 hours, but not a straight video lah, part by part. Okay, then I will post in the website lah.
In the Udemy.
Yeah, in the Udemy. So people should buy that and learn from that. Okay. So that time I was using this picture to do some videos. So that's how I do. Normally, what I do, I will do design first how I want. I don't design myself. Like yesterday I showed you the big place, right? So then I will check okay how to pick which one to on first. So when I start, okay, entry conveyor on. When the reach the sensor, need to stop, right? So I will write down my flow. Then I check everything. Then I do this one, the driver setting. Then according to this, I go to my PLC, do the PLC tags first. Then I do one by one. When I start conveyor on and at sensor conveyor must stop. I do that like this. All okay, then next. Yes, that's easier lah because you cannot do everything then cannot test. So one by one I do.
Because you do everything and then something is wrong, you don't know where is the wrong.
Yes, correct.
Because like I think day 2 I tried to do everything like the logic wise looking quite easy, but then when I start finish everything and then I try to do something wrong and then I cannot find the error.
Yes, cannot find difficult.
Yeah.
Then you will waste time on that. So one by one is easier. So finish one by one, testing one by one is easy. Okay. You go to the manuals.
Manuals.
Yeah. You know the hardware manuals?
Or you need the
Yeah. Go to the dynamic manual. Yes, we check some data. Okay. What I do? Go to table of contents.
Yeah, here is the
Yeah. Okay. Go to commissioning. Then you see basic operator panel, right? You go down to this one. Okay, quick commissioning. All the data is there. Okay, go down because I want to show you these things. Okay. Parameters. Go down. Communication. Okay. Yes, telegram. Okay. This one page what? Page 6. Remember? No, this is page 6.
yeah.
I want to go to 136.
Yeah.
Just click that. Alright. Sometimes can. Just go up to 136. 136. Okay. So wait. Telegram 1 is a speed control forward. Telegram 20 or something. Okay. Telegram this one forward. Okay. All that. Can go down. Okay. We can go down slowly. Go down. Okay. Yes. This is the number of words. Total I have 8 words. Can you see here? Okay. Total 8 words. Okay. So if I'm using Telegram 1, 2 word means 2 how to say 2 inputs, 2 outputs. Okay? No. It's like this. 1 input, 1 output. I mean first input, first output, second input, second output. Okay? Then Telegram 20 also mean go slowly down.
Actually, I can understand what N is and zone is.
Oh, what is it?
Basically, N is means like the current value, I think, and then N zone is something that should be your value.
Ah, okay.
Good understand.
Okay, good.
But let's have a
Okay, yeah. Okay. You see, S2 STW means it's a control word.
Right?
Okay.
Yeah.
Okay, so means telegram 1, the first one STW is a control word lah. Okay?
Okay.
Then ZSW is the status word. This one.
Fusion.
Okay? Okay. Then Ansol something A, right? It's a speak set point.
Yes.
This one lah set point. Then the speak actual word. Okay. So this is two only we use. If you do, okay, if let's say you want the output current, okay, output current. What is the current? What to the drive lah,
To the drive.
the torque. Okay, all these are means input lah, Okay, if you want to do that, you must use Telegram 20.
How you know?
Because Telegram 20, it got two input, sorry, two output. The up one is the output lah, the down one is the input. Okay, then 1, 2, 3, 4, 5 inputs. The first one is ZSW, then NIST, speak actual value, then output current, MIST is the top actual value, then PIST is active power. If you want the fault code, you can use this one also. Because you will get the fault code or warning all input. So it means the top one is the output, the bottom one is the input. According to the PLC lah. According to the drive, this for them, this is the input, this is their output. According to the driver. Okay? Now, control word. Okay. You click, you highlight this, you search, you highlight that, copy. Then you search
Where is this?
on the right hand side. Okay, next. Okay, next. You see ya? Control word, okay. Bit 0, bit 1, bit 2, bit 3, 4, 5, and so on. Okay, good. Now, go to calculator.
Okay.
Yes. Okay. You key in 47F in the hexadecimal. 47F. So you see here. The first one, this is the first bit lah, right?
Which one? Yeah.
First bit is here lah, on, right? Set the inverter to regular key. Second bit also on, no pause stop. Okay. Third bit also on, no peak stop. Fourth bit also on, enable operation. Fifth bit is on, enable RAM. Sixth bit is on, unfreeze RAM. Okay. Seventh bit is on, enable set point. Okay. Then 7, 8, 9, 10. 10. Go to 10.
I think it's number 9.
10 is a PLC control. Okay? Got it? Okay. You key in. You remember this number. The first 3, 1, 1, 1, 1, 1. Okay. You go, you key. Sir.
This, okay.
Okay. You delete. You key in 47E.
The 7E basically just this one.
The first one lah, right? It's
Yeah.
off, right?
Yes.
Okay, what is the first one? Go up. Yes. Shut down.
Oh, okay.
Okay. Shut down the distillation along all this. Okay. Then put the C7F. Everything is same. Only bit number 11 is on, right? goes in bit number 11 as well. Set point inversion means the motor rotate at counterclockwise. Okay.
But then it's
Earlier
backward.
this bit is on, right? Off.
Yeah, it was 0, 1, 0, 2.
Yes.
Oh.
So if you see 47E will be, the rest I'm not sure. 47E go down. Sorry, 4FE, right? 4FE will be go down. Sorry, go up. Sorry, where is it? Fault will acknowledge. Bit number 7 will be on. If you keep
Reset lah.
reset. So to reset, some of the function, of course, like this one must be ready, must be this enable operation. Then there's another enable set point. There's another one called PLC control is on, right? So all that particular bit must be on. So when you combine, you can use this also can, or we can. That's why I say if you understand, you can do many ways. You see, between forward and stop, only the first bit is different, right? The rest of some of the bit is same. Some of the bit is which is on is the same thing, right? What you can do, you can do this also. I do some program, something on lah, okay, something on, okay. Then I on which bit is, that is 1 1 1 1 1. Okay. Some of the bit 1 1 1 1, the first few, right? Means I just put a list. Okay, Q 2 5 7 first, right? 7.0, no, 7.1 lah, right? 1, all that 1 1 1. Okay. When I want to start, Q257.0 is on. The first bit. Okay? Because I don't want to confuse you. This one got 2 byte, right? If you calculate if you go to the second byte, then only go to the first byte. Yeah, correct. So means this is the second. This 8 is the second byte. This is the first byte.
Wait.
Yeah, I see. Because it's 256, right? 256 means inside that got 256 and 7.
Yeah.
So because you need to read from the right, binary,
On the right, yeah.
yes. The first 8 is the 257. 257.0 until 257.7. So it's 256.0 until then 256.7. Correct? Understand? That's why I put. Okay, the first few lah, all this, right? Okay. So which one to on if I want to move forward? The first bit, right? The first bit is 257.0.
Oh. So I have to work backward
Yes, yes.
when I turn on.
Okay. So when I on, okay, I write it. For example, if I want to do that this way, then if I stop, I off this. But this one must be permanently on.
Some of it,
Some of that, right?
Yeah.
Permanently must be on because like standby, enable operation,
no quick stop.
no quick stop, no call stop, enable ramp, okay, all that. So maybe this one maybe run when it's in run mode or something lah. This one for that I can do this way also. Okay.
That means it will be always on.
Always on. I just play with this one. If I want to move forward and backward, if I start, okay, I want this. Let's say I want to start forward. I want to start and I want to go backward. Backward is which number? The last one, right?
Yeah, the first one or the last one.
Yes. So Q256.0123.
3.
You got it?
Yes.
The
The
last-
last we go backward.
Yeah, this one we go backward lah.
For example, the normally open is not start, it's called backward.
What's it?
The button. Normally.
lah, we start backward lah. So I can do this is okay.
So what if we are looking at the telegram?
Yeah.
Telegram basically is the communication way of PLC.
Yeah, Telegram is the data I can share between two. You know, data I can take as per the drive. How many data I can receive from the PLC? PLC means my partner lah, and how many data I can send to the partner. Okay. So just now we see we just choose Telegram 1 lah. Telegram 1 means two data I can receive according to the drive because this is PLC output. So two data I can receive. One is control word, one is preset point, speed word. Two data I can send to the PLC, that is status and actual. So if two data the drive can receive means the first one is the control word, right? So I need to go and check. The control word, okay. If I want to run the motor, how? So when I go to here, it shows the control word is 16 bit of data. Okay. So if I want to on, I can do this way, or I can put this value or this value into here. That's where we use the move function. We haven't learned move. I think, have you learned move before? No, we can use the move function. Got it? You got the idea, you got the picture lah. Okay, got the picture lah. Okay. Okay. Now, go back to the page. What is the previous page?
6.
No, 136. Sorry. Look for speed set point. Such that
Do I look at it?
it's only that. Okay, wait. Why? I just need to search these two enough now. This is not important.
This one is the input from PLC to drive.
Yes. So it's the output lah.
It's
PLC is output. So these two is important thing, right? Because once I run the motor, then it's okay. I can just put this one. I just follow what is showing. Okay, I can follow also. Okay. Search next. Okay. It won't show the value, you know. It's something like that. This some paragraph. Then suddenly you see the number. Okay, next. That's all. Next. That's all right. Okay, you just put 4,000, you search 4,000. Yeah.
Nothing. Always me.
Okay, next.
Maybe it's still searching.
Wait, what is it?
Maybe it's still searching because
Yeah, because you left so many times. Never mind. You go to the table content number 6, page 6. Okay. Go down. Okay, so this one just now you see. Okay. Read parameter, line parameter, communication via Profinet. Okay, go down. Communication via USS, fault, alarm, PCK. Go down. Okay, go up. Okay, real time address, Profinet communication parameter. Okay. Go up slowly. Page 170. Okay. Okay, wait. So this one is the one we are using right now. So within the framework, TI portal. Okay, go down. This is the IP address. Then we go speed, to search speed.
You want to find speed at 4000.
It will be some. Wait, sorry. Okay, this one here. Okay, next. Draw speed. Okay, next. It's not like together, that's the problem. You can search. Go to next. Save speed. Next. Okay, next. Speed. Oh. Next. Is that not manual just now? Okay, go to okay, the older manual one. I think this one is a new one. Okay. No. You go to, you search control word. Control word.
Word?
Yeah, control word. Okay, search. Yeah. Okay. Next. Okay, wait, slowly. Just after here, must be main set point. Okay, go down. No, go up, go up. Just scroll down, scroll down. Okay, scroll
You
down.
want to back here and no, you want here and scroll down.
Yes. Scroll down. Okay, scroll down. Scroll down. Go down. Okay. Go to next. The table, the control word table. No, go. Wait. Okay, go down. Go down here. Wait. Okay. Standard regular. Go down. So yeah, okay. From here we go down. Okay. Go down. Okay, go down. Sorry, parameters. Go down. Okay, control word. Okay, go down. Control word, status one. Go down. Okay, wait, here. Control word. Go down. This one is status word. Okay, go down. Because the old manual they have. You put main set point, you search main set point. Main set point. Search main set point. Search. 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 Next. That's all.
I don't see the one.
Old one. Okay, you go to Google. Go to diamond. You click here. Ask Copilot. Ask anything. Yeah. Okay. 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 You put what is the main set point value in hexadecimal? Okay, finish. Okay, scroll down. Okay, and what? Telegram manuals. Kemudian, if I use Telegram 1, okay, just put Telegram, enter, and enter. Yes. Okay, so it shows 4,000 lah, right? It's 100 full set point. Very important special format. Word 1. Standard telegram 1. The main set point is transmitted one word in 7 words. Can you guys show me the page? Show me the page. Just showing the main set point on there. Because you know why? It will show something like this one. 4,000 is equal to 100%. So something like this. They just put it like that. They don't put like proper graph or something. That's it. Go down. Okay. The old manual also same. Just in one paragraph they just put it that 4,000 is equal to 100%. Maybe if I just search 4,000 should get.
But it's not required.
But it takes so much time.
But there's only one. But this one is not the one.
No, not this one. That's a parameter. needed telegram structure. Ego connection fixed and cannot be changed. What up? The telegram structure. What up? So they don't have anything. One by one, you go study. Okay, never mind, maybe it's right. What we do, we go back to our program. We test first. Okay, what I want to do, I want to make it simple. Just want to test it. Okay, because the drive, you go to drive. Drive need to do the commissioning. Okay, you need to choose the drive is for one, everything like basic step by step. Okay, but that one tomorrow we do because already inside the SS, it's already commissioned. Okay, we check first whether it can run or not. Okay, go to program. Main, just take a move function. You add two move function. Decide right. Decide also okay. Okay. We put here UW256. Then the other one UW258. Yeah, 258. Okay. In front you just put MW10. Just want to key play. MW12. Okay, enter the save download. Finish. Monitor. Okay, one got error right. Now you see what error? Is it bus fault or ready error? RDY.
RDY.
Okay, ready error means okay. Bus fault means complication. Okay, ready. Okay, if error, okay, at 258 is the speed, right? So you key in here 4000. Yeah, double click.
This one is a speed.
Speed.
Why is it this one? Just like you said, this one is a speed, but then you ask me. Oh.
Yeah. It will move the value, whatever value. Move is very simple. Whatever value in the input, it will move to the output.
Oh.
Okay, why? Because why I didn't use a watch table? Because sometimes in the watch table I cannot modify this number, modify this value. I cannot modify. So I need to use the move. So I key in memory. The value will be moved to here. Okay. So now I got fault drive. So at 256 you move 44 FE. For FE.
Okay. Just now the one is in
X
is in X. So
X.
but this one is just 4 FE. Yeah.
Okay. Now put S7-1200.
Wait, what is 4FE? 4 beside now. Oh, it's 4/7.
For
Max speed.
yeah, at max speed. Like, is it what shows what number? RPM
1310.
1310. Okay, that's the maximum speed of the motor according to the setting lah. You stop. Help you. But later we can do like this, move. So we can put like for move. So when I press start, I move this value. When press stop, different value. Now it's like no condition, right? Like always moving, So later I can put some condition in front. When I press start, then only I move. When I press stop, then only I move.
So to do that, I have to like press start and then enter the value into this thing.
No, I can put a constant number. Okay. When I start, let's say I start forward, because what I need to do is I need to move the forward, right? So 4, 7, like constant number like we but if I put like this, what happen? It will think it's a name. Because what alphabet word. So normally you key counter set point. How much you key? 5, 10, 20. The counter. Remember yesterday you do the counter set point, PD value. You want to count 5 means you put 5. Correct. A timer, you want to count 10 seconds means you put T, 10S or 10,000. This is in hexadecimal, right? So, key this. Do you see 16 hashtag? But if you want to key this number, 115. If you want to stop, same move. Okay, how much? 60 hashtag 4, 7. So because it's a push button, right? So when I press, this value move here. And only one time move already lah, that's all. Then the move function will check off already. So no more moving. When I press this one, this value move 5, 6.
Wait. So when I press, it will be a pulse, right? So it will move to the output.
Yeah, to output, that's all.
And then it will stop, and then the value will be recorded inside, so it will keep moving.
Not recorded inside, it will be here.
Okay.
Because nobody go and change one. So the value will be there
Be there.
unless someone move the value.
Okay.
Someone move another value. So when I press this one, when I press both, what happened? Then I will have like conflict, right? Because this one also move, this one also move. So when I press both, it will be like 47E, 47F, 47E, 47F, something like that.
Then what will happen? What will happen?
It depends on which one you pressed first. Which one you press the second. Because example because it will latest one update. So it will use that number, but according to the PLC, it will always changing. But since it's already used that value already, then it will stay in the value.
This QW256 is the output of the drive. No, input of the drive. Right. Okay. This one you cannot simulate, right?
What's it? Simulate. You can learn how the move function work, but you cannot see the motor until like simulation is you can just see how the functions work. Mostly simulation is just for the for that you can at least you can see the values, you know, it's on or off, true or false, all that. But numbers you need to learn. You want to play with number analog, all these are you need the device. But you can learn how it works, all that. Because at the end you're just going to use the same move function, the scaling function, the dB, the max, compare, all these ones. And tomorrow we see how to do the commission the drive, and we do a simple program, start, stop, motor, then move and the scaling. Then the same file, the same program, we can connect to a web server. Web server.
Yeah, no, but like why?
I don't create another file after web server. Just use the same one. Then from the web server you can just on and off the drive. Because the web server is just like 1 hour plus.
No, but why web server? What is the purpose of?
Oh, why is the web server? What is the purpose? Okay, web server is because this PLC is building web server. It means once you enable the web server, any laptop without TIA portal connect to the PLC, then they open the internet, they type the PLC IP address, then they can log in to the PLC. So it will be in a web page format lah. Okay. Then in that
web page, but it's a TIA portal.
TIA portal one.
Oh, okay.
It's not your own. It's the TIA portal. Like, okay, have you ever done like router, right? You connect, then you key in the IP address, you can go to the router, do settings. Done before, no? Something like that. Okay. So there you can run and stop the PLC, go to diagnostic buffer. Remember that day we used diagnostic buffer. You know what is the error, everything, right? You do that. You go to the watch table. Then if you want to on something, off something, using the memory or something, or key in some value, all that you cannot modify the program lah, of course. But want to change whatever, you know, the watch means the very simple lah. You can use the watch table. Most important watch table and the diagnostic.
Basically, I can read lah.
You can modify also.
Or I thought you say you cannot modify the program.
Not cannot modify the program. Modify the value.
All the value.
The MW values.
But the program, I still.
Of course, program must use the output.
No, but you say I go into the cloud service to check the PLC.
Same also.
No, that's why you say the purpose of the cloud service is to, if I know the
IP address.
IP address of the
Okay.
PLC,
Okay.
I can go into the web server.
Okay. And
Can I-
in the web server,
There's a TIA portal.
no, not the portal.
Then what is it?
It's like a page there where you can access to the diagnostic, run and stop the PLC. You can use the watch table, or you can use a temporary watch table, or the, it's not a tier portal.
So cannot edit the program.
Cannot edit the program. What you can do is you can monitor values like SWM or Q, what is that value, or you can modify the values. Let's say the motor running 50 hertz. You don't have the laptop with TIA portal, but you know this one for web server. Just log in, but you need to know what is the address. That's the most important thing. And you go, then you can change.
How do I know the IP address? By connecting it to the IPC.
No, you need to know the IP address.
Okay.
Well, let's say example, I don't know what is IP address. I want to know what is IP address. The only way is I must use TI portal to know the IP address.
But I don't have it.
So you cannot do. It's like optional lah. So that is what happened is. Like I said, they have a new version, right?
Which one?
The PLC 1200 G2.
Oh yeah.
Right. That one have app. Right? It's only in iOS only. Inside that app, the same similar function what your web server you have, but not all lah. Some function means I can see the diagnostic, I can see the status of the PLC, whether it's run, stop, error, all that. Then if not mistaken, I can see their watch table.
There's an app, but I still need to know the IP address.
The NFC I think no need IP address.
NFC, which one? There's a PLC with NFC function.
Yeah, the G2 lah.
Oh.
So you just buy the PLC, the G2 PLC enable. But I don't think so need to know the IP address. But just download the app, just bring it in here. I mean NFC signal,
But
right?
you still need the license lah.
NFC in the phone lah.
In the phone.
No,
Just the website.
I don't think so need license for the NFC. So I haven't tried, so I'm not 100% know lah.
Okay.
But what they say, what I know according to the manual or that, they just bring the phone here, you can get a few data lah. So one of the main data is a diagnostic. It's a PLC error. Only thing you can know why the red line is on is by using TIA portal to go and see. So if this PLC must enable the web server, you know. If someone enable inside, then only I can connect. If I know the IP address lah. Okay. The G2 I think must use code, but I'm not sure whether the IP address can be key or not.
Oh.
I haven't tested it.
But you're saying that tomorrow we do house server of the PLC. Wait, PLC. It's not.
No, not the drive.
Oh.
Tomorrow we continue with the drive.
What is it commissioning?
Commissioning, then we do a simple program and everything. Then once we set up backup, because that one I think before 12 fall we can cover that one. Okay, then maybe after lunch we just see what is web server, how it works, everything. At the same time, I think I didn't have time. You see in the laptop, in the desktop, you got software called cap server. In the desktop,
What is that? How to spell?
CAP, KEP,
CAD.
KK,
Okay.
KEP.
KEP.
On the right hand side. Normally my software is called, it's a green color software, green color logo.
Oh, KP server X6.
Okay. It's a OPC server. Then I show you that also.
What is OPC server?
OPC is Open Platform Communication.
Oh.
So means once the PLC means OPC is a server lah. So your PLC is the client. Means once the PLC is once the OPC is connected to your PLC, you can take all the data, whatever data I need, I take. The OPC can take. Then anyone, cloud. Have you heard about MQTT?
Yeah. Mosquito. Wait.
Yeah, Mosquito. You can use the Mosquito is one of the MQTT. Message queuing, telemetry transmit, something like that. You can that Mosquito that app you can get the PLC data using the OPC. Then node rate.
Yeah, node rate is something to do with the MQTT, right?
Yeah.
Yeah, I told you like during my class
Oh,
IoT, I didn't understand that at all, and my teacher also said it's an optional thing to learn because it's quite difficult. So I just want
the node rate. Yeah.
no, it's not to learn.
Yeah, because it's not like difficult. The thing is, you need to understand. You need to have the basic knowledge on on the cloud. How we not only cloud, the communication lah. What I'm doing, what is the purpose of node rate, all that right? So you must have. So now let's see. Later tomorrow once we do that, maybe you have the basic knowledge. And later on when you go to the node rate, you can understand that. Even
Are we touching on node rate tomorrow?
no, if you want, you can also. It's just a just one word. Just do a simple lah. Just do a button lamp enough.
Button and what?
Button lamp.
Oh.
Because in the node rate you can create a dashboard.
Yeah, I tried before.
Yes.
I use the potentiometer to see the.
Okay. You just need to install node rate in the laptop and need to install the Siemens palette. Then once done,
Can I try to? Where they go? I copy my files inside here.
okay.
And
You have printer?
no. Wait, I don't have. No way. No.
Okay, you don't copy this file first.
So, because it's not.
No, like that. Because your laptop already installed the drive. The drive software. Dynamic drive software already installed in your laptop. Close this one.
What's this?
This drive, right?
Oh.
Already installed. So you can copy, but you cannot open this the last file. And you don't know why you installed it. But the one 5 GB. The analog, okay, right for you. Understand? Can you
No.
just just understand what is analog?
The conversion is okay.
Conversion is standard lah, right? Conversion you just understand the thing is you need to understand why we want to convert. That's enough already. What you learn here in automation is like 10% only.
Wait, what do you mean?
What you learn these 5 days in automation in overall automation is just like 10 to 15%. But after this after this PLC but PLC means okay you learn mostly I can tell you 70%. PLC lah, what is PLC, what is SCADA, right? HMI. But if you see a big picture in automation in industry, because after PLC the most important thing is the communication. How you communicate to a device. Just now we create right the drive, right? And once I add, the drive give you option. How many data you want to send, you want to receive. So I choose right. So they have their own meaning.
You mean the how many data is like the delivery one?
Yeah, the delivery one, right? So they have their own meaning. So we go to the manual and get the data, everything, right? Same thing. So so many communication option, you know. Right? One of this is a Profinet. We are using a Profinet lah. Profinet is the Siemens communication. It means very simple. Because if you're using Profinet, they will give you the address like this. Okay, once you're using Profinet, they will give you this address. There's another communication called Modbus.
Modbus.
Modbus. M-O-D-B-U-S.
Modbus.
Modbus. Modbus is it's a third party communication. It's something like your language is different, my language is different. I'm Siemens, you are LNB, or you are Schneider. So you cannot understand my language, I cannot understand your language. So we talk each other in common language. So that is called Modbus.
Oh.
So that is one. In communication, so many Modbus, or CAN bus, or EtherCAN. Okay. All these are communication. The thing is, after you communicate, you will get some address. But when you do program, similar program like this, okay, move, whatever you learn, you are going to use only this only. But the difficult part is, how am I going to communicate with them? What communication method I will use? So what's so important? Another analog communication they call HART, hard communication.
HART.
Yes, hard. So when you have time, just explore on this Modbus, hard, whatever. You know why? Because hard means it's like an analog. It's the same thing like analog. Only analog sensors normally will have the hard communication. But like this, right? The temperature sensor, I connect the analog, I connect the two cable, I get the analog value lah. That's all. If hard means this is a controller, I connect the two cable, then I use the hard communication lah, HART. I can get the, let's say this is the temperature, I can get the temperature, I can get if it is fault, I can get what is the fault, I can get a few data, like I do communication with the drive, something like that. Using the two cable, I get few data. Normal analog means using the two cable, I just get only one data. If it's the temperature, temperature. If it is the flow, flow.
Actually, isn't it what you're saying? Isn't it like telecommunication? It's like nothing to do with automation, right?
Telecommunication, nothing to do with automation. Okay. What I mean is that this, but so first I communicate. But what I tell is communication, but this one we call industrial communications. So when you have time, you just go and explore what is industrial communication. How many communication you have. But different PLC, different name, you know. Like this one, it's just normal internet cable, right? But Siemens called Profinet. Mitsubishi called Ethernet. Okay, Ethernet. Then elaborately called, they call Ethernet IP. Omron they call FINS. FINS means
FI.
huh?
How to spell?
FINS, F-I-N-S.
FINS.
It's a factory internet network system something I told you. But the concept is the same thing. Because if you want to communicate, you need to have IP address. So then another guy, just if you want to explore more in PLC, if you forget or want to explore more in PLC, everything like that, one guy in YouTube. His name is this Mega Mono.
Sorry, what is it?
there's a guy in YouTube. His name is Rama. So he got so many videos on Tiago. Let's say you forget already how to do this what? SIMATIC. How to do the HMI. How to do the scaling. How to do the function block, FC, all that. He got video.
YouTube.
His explanation is very simple explanation and not very long videos also. Short videos. Sometimes I see this also. Sometimes I forget. I see this one. Or if I'm doing something new, which is I never explored before, I see his video first. Can I copy?
No, I cannot delete the file.
Which one?
Day 4 lesson. Day 4 lesson 2. Wait, what? Oh, it is deleted. So it's the original. Oh,
USB also okay lah. Mainly the hard disk. Actually, this setup is nice. I mean for office lah, office work. Because for me, this one need to carry anywhere I go. I carry this one very difficult. I go vacation because whenever I go vacation or some outstation, go hometown, I need to bring my laptop.
you mean mine is good?
Yeah. I mean for yours compare right.
Yeah.
Good for
It's thin.
team, carry around lah. But for programming, yes, this one. There's one of my participants the day he bought a laptop, 18,000.
Huh?
18,000.
18,000 for a laptop? Okay.
But that one, if you ask me lah, but he want to learn more in programming. Oh, very nice. The screen is a 17-inch screen.
17. Mine is how much? I think mine is 13.
Yeah, it was like 13 or what?
17 is like what?
It's bigger because my laptop is 15.6. 17, I think it's big.
Oh, wow.
It's big. Very big. 18,000 I asking why? Got so much money I buy like this.
He's a student or what?
Okay.
Working already lah.
No, I know him because second time he come for training. Because first time he come for Mitsubishi. Because that time he working in the company, so he come and learn Mitsubishi with me. Then second time he come because he want to go to another company. So that company they using Siemens. So he said he want to learn lah. He don't want to learn waste time. He go himself and learn, right? So he said he wants someone to teach me. So I know him. So once in a while he message me. Then he come. Then first day he asked me what is the spec. I said just nice i7 enough. SSD, graphic card. Graphic card not important. i7, SSD, RAM lah, minimum. Then he go and buy. Second day he come. Yeah, this is my laptop. He install the software. I say very big. When I see the spec, 2 terabyte, 32 GB RAM, 17-inch screen. The graphic card also I think very good graphic card. It's like gaming laptop. Ask him, why you want me to buy this? He said you want to use for like another maybe 10 years. So he said for him also it's very easy to watch movies. The spec lah is the i9. i9, all maximum spec. i9, and graphic card also is a good graphic card.
I think now they changed the name already. They call it Ultra 9 or Ultra 7.
Yeah.
It's so confusing.
No, I think it's different. i9 and Ultra is different because Ultra, if I'm not mistaken, I need to stack also. Ultra is for compact laptops. I think so, I'm not sure.
Thought like the newer version they rename it instead of I,
Oh, I'm not sure.
they use Ultra already.
Ultra i7-0. Intel Core Ultra. Oh no, got two.
Got two? What do you mean?
Intel Core i7 also got, Intel Core Ultra i7 also got.
Yeah, but like the newer,
Because the Ultra i7 is like for what? It's a high for high performance.
okay.
But they still have i7 also.
Yeah, this one.
But nowadays RAM more very expensive nowadays.
Yeah, because of the AIs.
Yeah, I know. Because whatever is the Micron, because Micron is one of the company that producing RAM. So what is Micron?
Micron.
Yes, it's one of the semicon company that is doing the chips for the RAMs. So what happens is these AI companies, all that, they order put a contract for 2 years or something. They only can do, they must produce this much of chips for them. So the RAM in the market, what happens is no supply, but demand is high, so all price go up. Because I remember the day one of my participants, his laptop is 8 GB, I asked him to upgrade to another 8 lah. So he said he have only one slot in laptop or something. So he go and buy 16 GB, he said 400 something.
400 something.
I'm not sure. Something around that lah. But last time, if you 8 GB, I think it's around 100 something. 16 GB, I think it's around 200, 250.
Wait, I thought the price like rises like 10 times or something.
Oh yes sir.
I don't know lah.
Oh,
Like,
I'm not
I don't
sure.
think it's like.
That day he told me it's around 500 something.
Or maybe that time still okay lah. Maybe now I think crazy amount.
Yeah.
This one.
Nice. Okay, see you tomorrow. When you going back? Tomorrow.
Tomorrow I'll check out. So I'll bring my bags here.
Then?
And then after that, I'll wait. After dinner, I'll wait until like 10. I think my bus is like 10 p.m.
Okay. Where Lucky?
Huh?
Lucky.
Okay.
The place, the bus.
Tun Amina. See you tomorrow.
Okay. So there's one guy booked for 13 to 17.
I'm already straight.
Uh,
Down Siemens also.
yeah. Then that day one guy called me. He's a third party trainer lah.
Okay.
So before that he didn't tell me the third party. He said request me for training information lah. Then I tell okay all the price everything. Normal our price lah, our normal 6,000 per day for